Hello?
Hello. Oh, hi, Yankeen. Yes. Can you hear me?
Yeah, I can.
Yeah, I can hear you.
Give me a sec. Oh, well, I'm setting up my stuff. I guess I should tell you the schedule for next week. So next week I still have to go back to school,
Yes, correct.
but it's only for like the first 3 days. So that's Monday, Tuesday, and Wednesday. As far as I know, we have to revision for both physics and math.
Revision, you're saying? Okay.
Yeah. So I think physics is like wholesale revision, like doing papers and stuff like that. And math, I think we're going through calculus.
Like revision by yourself, lah. Is it?
No, with the teacher.
With your teacher?
Yeah.
You mean like, or you'll be doing paper, but doing paper with the teacher?
Yeah, I think so. Yes.
And then it's gonna be like from topic to topic lah, something like that.
For math topic. For physics, it just be everything at once.
Okay, I guess that's not bad. That's not bad. We'll get interesting stuff out of it. All right. Okay. Sure.
Yeah, I haven't checked yet.
Then for chem,
Yeah.
just finishing up.
I'm pretty sure we're gonna do electrochem.
Oh, tutorial lah, right? Okay.
Yeah.
Right. Then you still have the last chapter lah.
Yeah, transition methods tutorial won't start until I guess July after the years.
Sure thing. So that's the update lah. Yeah, there shouldn't be anything else, right?
Yeah.
All right. Cool. Right. So, I mean, your expectation for your last chem lecture should be clear lah, yeah.
Definitely. Yeah. So I'll probably have to go through that during the holidays.
Okay. Sure. As in for the revision one, have they given you the paper actually?
So for math, I'm pretty sure my teacher just gave me on the spot. For physics, I got a whole stack of like papers from other schools, which we're gonna go through during the holidays.
Before we start anything, can you just show me first, lah?
Yeah, give me a second.
Right.
So this is the paper.
Right.
So
paper one. Oh yeah. Okay. Yeah. Sure.
So according to my teacher. Yeah,
oh, there's only 7 papers. Okay. All right. Got it.
Yeah. So we're going through ASIT. We're going through ASICG.
Right.
Like paper 1.
Right. No worries about paper 1. Oh, okay. Sure. That's a good way, I suppose. It's a good way. Oh, you also have RI and HCI, I suppose.
Yeah, I guess we'll go through. I'll probably have to do them.
Yeah, myself. You're not gonna touch that. You're not gonna touch RI and HCI. How I no, not gonna touch that at all. Not for now, at least.
Okay. I think. Let me think. If I'm not wrong, yeah, not really better, but well, I did a test on like the last few days of the before the exams for physics. So we also go through a test on nuclear and on top that I did before.
Right. Let me just see for a while. Let me just see the paper. Just quickly flip for me. Right, sure. Flip. Yeah, sure. And this is now paper. Yeah, you already have paper.
Paper 2 for CJ.
Understand.
Yeah. Then
Okay, so when we have time today, I'm gonna do something with you on the physics paper lah. Not exactly answering the paper lah, but setting up our expectations. So even for especially for revisions, I think we have to have very clear expectation. Then you can get more benefit out of it and not zone through lah. It's very unlikely to zone through because it's probably going to be intense since you're moving topics. But it's still good to have a proper expectation out of it. But later. So let's do what you want us.
yeah. Let's check. So let's see. What did I do today? Falling side left.
Yeah.
Math, the lecture was done.
Wait, I thought you have something you want to do. Wait, what? No. Is it?
Let me think. Physics done. Tutorial? I mean,
if there isn't, then we'll. I mean, I'll start with physics first, lah. I'll start with physics first.
Now it's revision more now, but
I know. As in, I'm trying to set the expectation thing by doing something, lah.
I guess that
There is nothing that you strongly want to do. I would like to do that.
nothing immediate. Electrical tutorial is fine, but I've only made it in that.
Yeah. I mean, electrochem tutorial is fine. Is the expectation, as in, because the subject is not hard. I mean, I hope I give you the impression. Yeah. That is the expectation.
So I guess you could do this.
All right. So okay, yeah, we're gonna do some physics stuff. Yeah. Okay. Right. So this is what I'm trying to set expectation instead of this is therefore this is like similar to when we go through the lecture note for the first time. Like instead of explaining, we will explain things, but that's not the goal. The goal is to set expectation for the class. Right. So now you're saying that tomorrow you'll be going through paper 1 of the Serangoon ASR is.
Yes, I see.
Right. Okay. Let's open that, and you take your pencil. And at the same time, you just take a look at what the super small, so to speak, data booklet, data paper that the physics will give you, right? Now, do you understand that this 2-page is what they will give you? I think there is nothing else.
Yeah.
Thing, right? So just check them out. Well, just check them out, like really one by one. And you have any question, you ask me first before we actually go through the paper. Like really go through them one by one. No, starting from the left page. This one. Yeah.
Okay, this is for electric field and what was this for? These two ones, electric field and magnetic flux.
Oh, you mean what do you use it for? Is it?
Yeah.
Oh, no, use it electric field.
Both of them.
Like the what? The K. The what? when you have the formula like a constant, like the electric constant, then Q1, Q2 over R squared.
Oh, yeah, like case.
And then the K is 1 over 4 pi E naught in this case.
Okay, so
Meaning to say they don't wait. Yeah, it's not the K is not the Boltzmann constant below there. Right? You see a Boltzmann constant there?
yeah, that's
Yeah,
for
that's not the K lo. So they both are K. So you have to use either one of these lah. Either one of this.
right.
Right. So just wondering whether you know which one lah. If you don't know, then you put a question mark so that you know lah. So that's already an expectation lah. In the revision, you should have that answered lah, right? Right. So again, you don't know what this is for. Put a question mark. Simple, right?
Elementary charge. Yeah.
I will argue that you need to put a question mark on the U naught also, E naught also. Yeah. Okay. Right. So your expectation is this will be answered. Okay. Next.
Okay, elementary charge. Yeah. Okay, like constant. If I talk mass, yeah.
Yeah.
Mass,
Yeah.
yes. Proton mass,
Yeah.
yes.
Good.
Molar, that's from chem. Yeah. Okay.
Where do you use it? Where do you use it in physics? Where do you use it?
Isn't it in the same equation?
Okay, I'll go very again. The expectation will be like this: like in which chapter or in which topic that you will need R
the
and
one on
NA.
the one on the heat, right?
Yeah, when you talk about thermodynamics, correct, but that's because you're dealing with gas. So you're doing the thermodynamic of gas, ideal gas. That's the chapter, the chapter in ideal gas. So in fact, the R, the NA, and the R and the NA both you will need it in the ideal gas. But in which formula, you might still want to question mark that, right? It's a very specific usage. So if you don't know, put a question mark. Okay, then you have an expectation of where am I supposed to use this? The NA, the NA, the K. Tell me which chapter the K is. The NA, I think you need to put a question mark also. As in the question mark is not that you don't know what it is, but where am I supposed to use this? Right? Where am I supposed
last time I used the NA was in nuclear, right?
In nuclear? Oh yeah, you can use it in nuclear. Yeah, you're right. But in ideal gas, most probably in ideal gas also probably.
Okay.
Then how about that's Boltzmann constant? Where do you use that?
That's thermodynamics also.
In which formula, if you remember?
NKT. But I don't know I don't know what's the difference.
That guy. Good. Yeah. So you almost answered that. Okay. So let's put a question mark there. Good. Good.
G.
Right now the big G, right, and the small G.
That's gravitation and
Okay. Excellent. Now, that's already an expectation. Good. Now this guy.
For this, yeah. Oh.
Forgot this one. Oh yeah. Oh, okay. Why do you put a question mark? Tell me.
Huh?
Why do you put a question mark? I want to know. Yeah.
I'm not sure where to apply it.
Oh,
I'm pretty sure.
It's super important.
P is
yes.
volume, but W is
correct. Work done. Yeah. And if you don't know where this is used, that's super important. Okay, good question mark. Good. Expectation set. Good.
PGH, that was in
Rho GH. Rho GH.
Oh, that was in the ship sinking and then the flotation.
Yeah, they call it the buoyancy fancy word buoyancy. The Archimedes principle. Anything that floats Anything that floats. Right.
Gravitational potential, use it to find all the
what the heck is that?
Mm-hmm.
Right. You can put question mark for a variety of reasons. Like for example, I know who this is, but I'm not comfortable using it at all. You can also put a question mark on that. That totally sets the expectation. Right. Oh, writing your question is excellent. Looks like you're changing to a wonderful student, right?
Temperature, okay, I know that. Definitely not. That's speed of.
Yeah, where do you this? What is that c square thing here? Because that c is not the speed of light. It's not. That c square is not the speed of light. And what's that weird bracket somewhere, right? What's that weird bracket?
That's average. I remember.
Oh, you know, yeah. Then how about the C?
No.
Okay, good. So expectation set, good.
Okay. Being translational.
Voila, that's the key.
That's the key.
There you go. That's okay. Yeah, but what the heck is this, right? Like, well, when did we use this, right? Now, if you don't know, yeah, good. Yeah, good.
No, that's wave. No, that's oscillations, but oscillation.
Yes, simple harmonic motion, the oscillation one. Yeah.
Moving it down to here, I don't know how it does it.
Okay, and what in fact what for, right? What's the purpose of that lah? You can put a question mark. Sure. How? What for? Right. Sure.
I A and PQ. Yep, I remember that's for.
But what situation? What situation is this
in
weird?
a wire, right? This is a wire.
A wire doesn't have a V, you know.
Really?
Like what's the V of a wire? Right?
Drift, isn't it drift velocity?
Oh, okay, good. What's the A?
A is like the cross-sectional area, right? And
of the wire line. All right, sure. Then the end of the cube.
And I remember there was a special condition, but what it is? It's not like just number of electrons.
You may want to put a question mark lah. You may want to lah. Right.
Q is charge, obviously.
Of the who?
Okay. Charge of the.
Of who? Right.
I mean, electrons.
If you have a question mark, then question mark here lah. Right? That's the expectation. Because you already mentioned the drift velocity of the electron. You already mentioned that. So yeah. But if you have some doubt, put a question mark lah. Put a question mark.
No, it's charge of. I don't know what I call it, charge of electricity.
Yeah, it doesn't.
It's like, because current is charge over time.
Like I mean, in physics, the charge is extremely simple, right? It's either a charge of electron or the charge of the proton. No, that's in physics, charges are very simple. In chemistry, it's more variation, I suppose. You have ions and everything. And yeah. Just a minute, sorry, give me some time.
Yeah, okay.
Halo, Ma. Halo, Ma. Halo, Ma. Ma, lagi ngajar, Ma. Aku lagi ngajar. Kan udah tulis di WhatsApp, Ma. Halo, Ma. Halo, Ma. Ma, bisa dengar, Ma? Ma, bisa dengar? Ma, bisa dengar? Ma, bisa dengar? Ma, bisa dengar? Right, sorry, I'm back. So yeah, okay. Ah, there you go. That's the E0. Yeah. That's the E0. Yeah.
And alternating current. That's the.
That looks like exactly the same as the displacement of the particle, right? Right. So I'm not sure whether that's surprising or confusing, but it is like that. It is like that.
B goes mu naught.
Yeah, there you go. You have the mu naught.
That's long straight wire is the magnetic flux will increase with, will decrease with
the distance.
As it goes radius out. As it goes out, so B is. B is diameter or radius? Diameter.
Check it out. So if there's a question mark, that is where you want to ask, right? Because this formula definitely is going to be used, definitely. Like this is diameter of the what, right? And very important diameter of the what, right? Diameter of the wire. something else. I don't know. Right. Okay, so the mu naught, however, that's your answer. Right. So the mu naught is used there.
So the n and the n here are.
I see,
Yeah, I think I know what the n here is. The n is the number of.
Cannot see. Move up, please.
Oh.
Right. Okay.
I don't remember here if n. N here is number of coils. The n here is number of coils over the length.
Wait, let me think about it. He did say that flat circular coil.
Number of coils and number of coils per length.
The solenoid one, I agree, but please check again. Please check again. I agree though. Just make sure if you have a question mark, just make sure. This is good to do like initially.
So this is that's not either negative. Yeah. Okay. That's just the cables. Yeah. Well, that's it.
You're saying? Sorry, you're saying.
That's all the formulas.
Oh, sorry. Right. Oh, wait, let me see. Yeah, decay constant. Yeah. Okay. Wait, the exponent. Sorry, the exponent. Wait, let me see the exponent one. The one. Oh, this one. Sorry. Yeah, this one. Yeah, sorry. That's fine. Totally fine. Right.
Yeah.
Okay, so I'm sure we're gonna go back to that page again, right? But for now, let's go to question one.
Yeah.
Right, so this is how we set our expectation. So be very clear, MCQs in chemistry and in physics, both, they go through the topic like just like a robot. They just go through one by one. It's very predictable. Right. So for example, question number one. So what is the topic of question number one? If you do not know the name, but you know what it is, that's considered right?
Measurements.
Right.
I mean,
and the expectation of measurements. So the expectation of measurements is, for example, here, unit, right? Unit, and then so standard unit lah, the standard unit, and then in question two, it still is measurement, correct? But this is now is like what is this? The uncertainty, right? Which is percentage and everything, right? So question one, question two. So do you remember the formula or whatever that you need to use or the concept, whatever, on this?
I remember the formula, but okay, so it's like uncertainty over actual times 100%.
That's for percentage uncertainty lah.
Yeah.
Right, that's a percentage.
This is absolute uncertainty, right?
Right, and you just convert it into percentage lah, correct? But that's not the only thing you need lah. That's too easy. But however, what you're remembering makes sense. Yeah, the absolute uncertainty is connected to the percentage uncertainty. But again, that's not what you need. That's not all that you need lah. Do you remember something else that you may need? For example,
it's like converting like, I don't know what to call it. I don't know what the formula for uncertainty. Like converting it from like, say there's like a formula for to find something, and then.
Do you remember the formula then?
I don't know.
Right. So here goes like this. So I mean, the worst thing that you can remember is that at least you remember the formula in the situation that you need it. So at least you remember that there is another formula, even though you do not know what the formula is. Okay lah. So you have some expectation. I'm not zooming in on the fact that you forget. Obviously, we all forget like the rusty one. Okay. I'm zooming in on the fact that you have at least some expectations, right? So you can look for it now, or you can look for it later and just write down that I need some sort of formula here. Just write down very simply. Right? I'll be needing the formula.
I didn't get it.
No need to find it. No need to find it. We're going very fast, right? You can find it later, but put a question mark here that reminds you, I need the formula, whatever that formula is like. It's not the formula that you have written just now, right? Okay, so this is the minimum that you need. We need more than this, but at least we start. Right. So let's see what we're gonna get. So you have an expectation from the revision that I'm gonna at least get this formula, right? At least like, can you? Okay. Right. Any other question for 1 and 2?
No, I don't think so.
So let's go to question 3. So, question 3 is a change of topic, right? So I'll go very quickly first, I suppose, like the worst thing we need to know is what kind of formula we need here. That's the worst thing already.
I mean, I don't think we need a formula.
Okay, try to answer this one then.
It's kinematics, so.
Yep, it is kinematics. Yes. They call it SUVET for a reason, right? So all the formulas relating to SUVET lah. Can you answer this without a formula? Okay, all right. Let's give it a try.
I guess not. I mean, like, I can think of a formula way kind of to solve it, but
if you don't have a formula, then how are you going to do it? You can, of course, eliminate like if you want. Oh, this is wrong, this is wrong, this is right. You can do that. Give it a try.
the distance will increase continuously. That's pretty sure that's wrong. But
then okay.
Distance will decrease until they touch. Okay, let me think.
I mean, A, B, and C is basically mutually exclusive to each other, right? So it's either A, B, or C, or maybe there's a D lah. I don't know. Yeah, but yeah.
Decrease until they touch, remain the same. Well, so they are the same acceleration.
I like that. Yeah, that's that. So let me write this. Let me ask you to write this down. In kinematics, thinking about acceleration is the most important thing. So I'm setting your expectation right now. You need to think about the acceleration in kinematics, right? Before then, you talk about velocity or distance lah, because acceleration goes to velocity goes to distance. So I like your expectation. I like what you're starting with here, and I'm setting your expectation for the next paper. Oh, acceleration is my focal point. Good. Now, if you have the same acceleration, then what? Then what?
So you have the same initial velocity and.
Which is your initial velocity?
0, I guess.
All right. So same acceleration, same initial velocity. Okay. So then what?
Just displacement is different, right? But I guess you do the formula.
So do you have the formula here, right? That's another thing, right? Do you have it?
Yeah, I have it.
Okay, choose 1, choose 2, whatever. Choose whatever you want, right? So write down.
Is it S? Where is S or?
Well, okay.
So so that the displacement is half AP squared. I guess.
Okay, I'm going to say something here. Just derasting you. I noticed that you don't think that you need two formula. Two formula, I mean, it's the same thing. It's the S. So S1 and S2. I mean S for ball number 1 and S for ball number 2. I'm not sure whether it is, I'm not sure whether you're just forgetting or you don't do that from the start. However, I think this is very important. I think it's very beneficial for you to think, oh, the displacement of the first guy, S1, the displacement of the second guy, S1, S2, because you have been saying that all along. You've been saying same acceleration, for both ball. Okay, A1, A2 lah, right? A1, A2. Then U1, U2 also, but you don't go to S1 and S2. I'm a bit confused. Right? And even but right now, A1 and A2 is the same. So you don't have to put A1, right? Right? Correct or not? Right? You don't have to. But you need to make the distinction that there are definitely two displacements, right? Definitely, right? Right. So it's the so you think carefully, you don't need A1 and A2, right? Because they're just A, correct or not?
Yeah.
But you now communicate to yourself that T1 and T2 is necessary. You need to make a distinction between T1 and T2. That's what you're saying, basically.
Yeah.
I'm giving you a lot of hints. I'm giving you a lot.
I mean, but I minus.
Like you're saying that the time that ball one have, stone one have is somehow different, should be considered different from the time that stone two have.
Yeah,
that's what you're saying.
Yeah, it has to be different, right? But fail then.
What do you mean by different? Sorry, that's the part that I don't get.
The time taken for that to hit the.
What are you doing? You're not answering the question. I don't get it.
Like S is the displacement for the ground, right? It's like how
you're not asking. No, oh my goodness, right? You don't answer the question. What is the question?
What distance between them? How do you find it?
Yeah, what does that have to do with the time to the ground?
Because the difference between that is like will tell you the difference between the displacement. So if the difference between the two times are always constant, that means the distance will remain the same.
What does that have to do with the ground?
I mean, that's just one count. That's just like what the equation tells me. I need to like minus to like get the difference between them, right?
There's a disconnect here. How do I explain? Let me put it another way. Now, obviously, what you're saying is not wrong. What you're saying is that time for stone one to hit the ground, let's get this clear, it's just bigger than time for stone two. Always the case. Stone two, the lower one, will hit the ground first before stone one. Totally agree with you. Okay. Yeah. That's not what the question is asking. That's not it. It's not. Sorry, it's not. I believe the question is asking about before they hit the ground. They don't say though. So the question, I feel a bit vague on this, but he doesn't care about what happens after stone 2 hit the ground. I believe he cares about what happened before stone 2 hit the ground. I have no basis because the question doesn't say like that. But that is what I believe. So I'm starting from that belief. Can ya? So now let me put it another way. So let's say if we are concerned with not the stone hitting the ground, just before that, before, then my question is, if stone 1 traveled for 0.1 second, how long has stone 2 traveled?
If stone 1 traveled for what?
0.1 second. Then how long has stone 2 traveled?
0.1 second.
Totally agree with you. If 0.5 for stone 2,
then 0.5 stone 1.
That's my point. So my point is 2 lah. I assume the question doesn't care about hitting the ground, but before. And then you have just mentioned my point lah. Their time of travel will always be the same before hitting the ground.
How? Yeah, okay.
So instead of making the distinction between time 1 and time 2, we acknowledge, like you're just acknowledging, oh yeah, the time 1 and time 2 just the same time one. They have the same time. Why? Because they're simultaneously released. Okay, right?
So that means
before hitting the ground.
So that means that the displacement between them is 0. So that means the distance between them.
No, the difference of displacement is 0.
The difference of displacement is 0. So
the distance
between them doesn't change.
Yes. At least that's what I believe lah. If my assumption is correct. If my assumption is correct. Because I think the question fails to clarify that. I feel. Like for example, if option D say initially remain the same, then decreases, then I will have a doubt, then maybe D is a better answer. You understand what I'm saying?
Okay.
Right. Yeah, because that means he's talking to us about the scenario before hitting, then after hitting. Right. But D is not like that. Then I make that assumption. Okay, he doesn't care. He doesn't care about hitting the ground. Obviously, other question will care about hitting the ground. I believe this question doesn't. It is one. Okay. Okay. Now let's see how your expectation develop after doing this questioning. Okay, the expectation that you should carry to next paper, like paper 2 will have this. Also, paper 1 of next school will also have this. How does your expectation change if something did change? Nothing changes, really. You're the same Yankeen before doing this question and after doing this question. Really.
I mean,
your learning and your thinking doesn't change you even one bit.
I guess it does, but like I couldn't say how.
How? If you can be a bit aware of how, if it is possible. I mean, self-reflection is not the easiest thing, but if it is possible, can you say what changes or what expectations? Right?
Be more aware of like what's important to the question.
I suppose. Let me put it in a different phrase. The question will pick and choose, especially MCQ. The question doesn't stay the same for you, for your convenience. It doesn't. The question actually pick and choose from whatever is available in that topic. And you should expect that. You should expect that. Right? Like the question maker will pick and choose. Right? The second thing I notice is, I don't know whether you feel the same way, but formula helps. Even when there are no numbers. My guess is that you think you don't need the formula the first time because you don't see any number. That's my guess. Or you think that this like something like a definition question where maybe formula doesn't matter. That was my guess. But then you make the swap in the middle, right? Like, oh, maybe formula helps. So actually, does formula help?
I guess it does. Definitely.
Does it change your expectation for the next paper?
Yeah, we always like consider the formula.
Then at least please write that 2 new expectation down. Would you please do that for yourself? You're writing a letter for yourself, For the next paper, consider this and consider that for this topic. Right. Any other expectations that you can carry forward?
Not yet with this.
I have affirmed the first one though. The acceleration is the focal point. Just want to say, you're already doing that. I think you should be doing that again in the next paper. Okay, right. If there's nothing else, let's move on to question 4. So what topic will this be? My favorite topic. My favorite topic. They always give this. What is this?
This is the lift question.
Yeah.
Favorite topic.
The bane of everybody's existence, right? Question 5. Question 5, surprisingly, is the bane of everybody's existence also. I don't know why. Question 5, which is totally different from question 4. Question 5 is called the connected maze. The connected mass. Teacher probably never say it this way, but this is clearly connected mass, right? Connected mass. So the bane of everybody's existence, 4 also the bane of everybody's existence, right? Now try doing question 4 first. Maybe we discuss this in detail, right?
Oh boy. I remember teacher going through this, but I don't know.
Right. Teacher keep going through this and you keep not understanding it, I suppose.
It's like there's like your mass and then like actual mass and then like what the mass on the scale because
look, let's just dive deep. This one I won't go like the previous question, because the previous I feel that you know what's going on. This one you feel that you are grappling with it, not getting it. So let me get this straight for you. What does the scale measure? What does a scale measure?
your force, like I know.
Don't say your force, but say force, right?
Force
say force. So why does the scale pretend that he's measuring mass? Like, is he lying to you?
I mean, no, but like they just.
How do you know that the scale measures force, not mass?
Just what the scale does, I guess.
I mean, I suppose I'll show you. Here's a lousy scale. I have it in front of me, right here. Yeah. I'm gonna turn off the virtual background. So you look at my video for a while. Right?
Yeah.
Okay. So I'm not looking at your video for a while. So here's a very lousy scale, right? Okay. Here, super lousy. Just bought this for I don't know, less than $2. So do you see what's written here? Here's an honest scale for you. Here's a very honest scale. Do you see what's written here?
I can't. Sorry.
Right, it's very super blurry. Okay. Oh my goodness. Why is it super blurry? Because laptop cameras are lousy. So do you see it now?
It says N, I guess.
Yeah. So here's a very honest scale. Look. A very honest scale which measures force, right? Which measures force. Tell me what is inside this scale. You cannot see what's inside this scale, but tell me what it is.
A spring?
Yeah, that's all. Now your bathroom scale, usually the imagination of that question is a bathroom scale, not this scale. Do you know that the bathroom scale also contains spring?
No.
Right. So the spring is a circular one. The spiral one. So it's a more compressed spring, but still very strong. So this one you imagine the spring as something long, right? That's how you imagine it, right? And then the spring is being pulled, right? This kind of spring is not good. It's not suitable for something that is pushing. And something that is pushing is your bathroom scale.
Okay.
Right? So imagine your bathroom scale, something like this. Just imagine that. And then the spring inside is spiral and you can push it. And then somehow the spirality will move the scale, something like that. Because the scale moves like this, right? That's just a rough imagination, right? Okay, so far so good. Both are spring. So this is being very honest. He is not measuring gram, he's measuring force because spring is very good for measuring force. The bathroom scale is lying to you, right? But people don't care. Normal people don't care about what Newton is. Normal people want 1 kilogram, right? Kilogram, right? So how does the scale lie to you? I mean, he is lying properly. Yeah, he is lying properly. How does the scale lie to you properly? Tell me. You're the physicist. You're the
Something
physician.
about the normal force. That's what it's like.
Right. So I'm measuring a normal force. Makes sense to you, right? Okay. So watch. This is the sideways. So imagine that this is my foot, right? Right. That's my foot. And this is the floor, right? I have to have a floor, right? Can you measure your weight without standing on the floor?
No.
Cannot. Good. So foot, floor, foot, right? What do they do to generate force?
So foot exerts a force on the floor and then.
No. Foot and floor. Foot and floor. You're making a mistake there. It's foot and floor. Yeah. So again, I asked you the question just now. Can this measure without the floor? You say cannot. So here's the imagine. Here's foot. Boom. Can he measure or not?
No.
Yes. As a physician, as in yes, correct. As a physicist, right? As a learning physicist, it's foot and floor, not foot. A normal person can be forgiven to think it's just the foot. Wrong. It's foot and floor. Why?
Why? I mean, that's just how the physics works, right? That's just.
No. Okay. No. Yes. No. Look. Here's the normal spring. Easier. Right? Do I generate force by pulling this down only? So it's my hand generating the force. This is my left hand. You see, it's my right hand. So is it my right hand generating the force?
Yeah.
No. See, I'm pulling the spring.
Oh.
I'm pulling the spring.
The left hand is also
holding it. Yeah. So a spring must be generating force by a pair of pulling force, or a pair of pushing force. Make sense or not? You're a physicist.
Yeah.
Yeah, and you never think about it, but you're a physicist, so think about that. It's not just one force like that one. It's never like that one, even though it's drawn like that. And this is also not action reaction. Yeah, it's also not. Yeah, a spring really needs two pair of forces. A pair of forces. Sorry, a pair of forces. Okay. A pair of forces. Okay. And yeah. The foot and the floor. Now, to avoid the confusion, right? So because you say this question is very confusing, the same mass now, whatever mass now, remember, he is never about the mass. So how does the mass lie to normal people? Like if there is a 60 Newton, if there is a, sorry, not 60 Newton, if there is 600 Newton floor and force, how does the bathroom scale lie to normal people?
Makes you think there's only one force.
No. The normal person don't care about that. That's you lying to yourself as a physicist. A physicist has to think about things like that. Normal people don't think like that one. Who cares? Normal people don't care. How does the bathroom scale lie to people? This thing is moving, right? Supposedly, this movement is 600 Newton, right? Supposedly, right? How does the bathroom scale lie to people, normal people?
It's not measuring the weight, it's measuring the normal force.
Yeah. So how does he lie? Very simple, instead of writing 600 Newton here, he writes
just 600 divided by 9.1.
Now you're a physicist. So he lies by, not by improperly lying, but by doing the job for you. 600 Newton divided by 9.1 is like 61 kilograms. So he's right here, 61 kilograms. Okay. Proper lie, because normal people don't care, don't even know what G is. Again, because don't care, doesn't impact that. Okay. Okay. So now the confusion is that there is no such thing as real mass or scale mass. There's no such thing. The mass was never there in the first place. This is not a mass measurement device. It's a force measurement device. Even though the question will also present it that way. That will clear up the confusion for you first. Okay, Ken? Now, let me ask you a question. Back to the foot and the floor. So now that this is force, you are free from the mass because our mass don't change. right? Our mass don't change, but the force may. Can you, even though you're how many kg?
60, 60.
Okay, 60 kg. So if you stand on the scale, you exert 600 Newton, the floor also exerts 600 Newton. So the scale displays 600 Newton. Can you as a person exert more than 600 Newton without
Yes.
standing on the lift? Okay, tell me, how do you do that without standing on the lift?
It's like you like push down, I guess.
Yeah, which is stomping. Boom! When you stomp the spring goes to more than 600 Newton. And that totally makes sense. Okay, totally makes sense. So how does the lift show or push the scale more than 600 Newton? How does the lift do that? Stomp lo? Stomp up lah.
Stomp up. Because they're measuring normal force.
Yeah, he's measuring not just normal force. Again, the force will be the same one. So because the fish, instead of you stomping on the scale and the floor, increasing the 600, the lift is now stomping you up, so to speak, because the lift is pulling you up, accelerating you up. So instead of 600 and 600, it's more than 600, stomping you up. Make sense?
So since it's more than 600 up, you have to exert more force on.
No. The more force, this is the more force is caused by the acceleration.
Of the lift upwards.
Because you are accelerating, because the lift have you accelerate the scale. And by the way, he's assuming the scale doesn't have a mass. That's another thing, right? The lift assumes that. Because the lift is pushing you up, you are pushing the lift down. If there is no scale, remember, if there is no scale. If there is no scale, see, you push the lift 600 Newton, the lift push you up 600 Newton, equilibrium, correct? This is you, right? If the lift is pushing you up, you are pushing the lift down. Remember? Action, reaction, right? Okay, so you are pushing the lift push you, but steady, 100. But the lift is now forcing you up, you are forcing the lift down, even though you obviously lose that. You are still doing that one. So back to the scale. The scale is just trapped between you. Who cares? You know, the scale is just trapped between you. 600, 600, but then additional 100, 700, 600 plus 100, pushing you down. Okay.
And the scale measures 700.
700. Okay. So the scale can measure forces more than what your weight is capable of. Yeah, because it is a force measurement device, not weight and not mass. There is no mass measurement device. There isn't. There is no such thing as something that can measure a mass. Only force. I'm not sure why this is never cleared up in the first place, but I think it makes sense. Now, how does the lift measure, or the scale measure less than 600? How does he do that? For example, how do you, 600, right? How do you appear to have less than 600? How do you do that? You're standing on the scale.
If
how do you do that?
The lift is pushing you down.
No, that's not, no, the lift cannot push you down. The lift cannot push you down. The lift can only push you up. The lift is simply moving down, dropping. Now, how do you do that? Let's use this. You can do this. You can jump. See, when you jump, you push higher first, right? And then you go, you hum, then you jump. See, less than 600. When the moment when you're taking off, like that, you are less than 600 already. And then now it becomes 0. Right? Okay. That's you registering less than 600 in scale. So how does the lift do that? Just reverse low. He just something like so to say. It's not like that. No. This is like dropping you, but it's just dropping you a bit. Dropping you a bit. Then you register less than 600. Okay. And you register that every time you take a lift because you live at the second floor, I think, right? But do you take lift every day? Do you take lift?
Yeah, I take lift.
If you take lift, then you can feel it when the lift move down and when the lift move up, just for a while. You can. Understand it? Clear it?
Okay.
So that's the concept. We haven't got into the calculation, but you need that concept. And the expectation is you will need it every time because they like to ask this question. Good luck. Okay, so write down whatever it is that you feel you understand more first. Write down, because that is the expectation you need to carry forward to the next paper. Right? Would you please do that?
Yeah.
You mean your teacher tell you that there is no mesh measurement device? Your teacher did tell you.
I mean, I guess he told me like, maybe it was implicit.
Maybe. But it seems like you understood that, you see. So I'm a bit, oh yeah, okay, maybe you did understood something, right? Maybe you were thinking of it. Right? Okay, good. Anyway,
So
right now.
when the lift is going up, so extra force downwards, so greater force on scale. Then same thing for opposite for going downwards.
So let me just confirm that this is like new, and in this context, that looks like what you need. Let me just confirm that. Yeah, because what you're drawing doesn't make sense to me. Like, because it is not formal, but who cares, right? It's for you.
Really?
Right? Oh. Yeah, it doesn't feel particularly, but it doesn't matter because it's about you and your thinking, right? Okay, so now I will argue that for this question you don't need a formula, and you even have decided on the answer A, right? You have decided on the answer, and yeah. Okay, I'm give you one more expectation. So I expect that this answer will be wrong, and I will expect that you need to learn why. This is a very common thing to have to settle. So expect that you need to settle this in the discussion. If the revision doesn't explain to you why A is wrong, because obviously the next answer is B, right? Okay. If the revision doesn't explain to you that, your revision something wrong with it. Because that's the last thing you need to understand. And then every other question after this should be good enough. You should be good enough for it. Okay, I'm forming your expectation, your revision, you're demanding something of your revision. Understand? Okay. Right. So just put a slot. Maybe I'm wrong, right? Maybe I'm wrong. Just put a very slight cross on A. Let's see whether I am right to call him wrong. Let's see. Okay. Let's see. So now, surprise for question 5, the same concept apply one. Like I was telling you, okay, how come this guy, how come the lift push you up 700? This is not remain 600 because if somebody push you up, you push him down, right? Reaction. So if this 700, this is also 700. But it will be, this 700 will be like you 600 and then another 100 to accelerate you. Yeah. Now, surprisingly, that is totally needed in question 5 also. People don't see the connection, but that's totally what's happening. I would argue that a lift is just another form of connectedness. Now, can you do question 5? If you can do question 5, then my discussion no need. Can you do
no.
I give you 1 minute to try. Let's see your first step. If you cannot do a first step, I'll give you a hint.
Boy, so
So I'm gonna stop my video first. So this thing bothers you every time because this thing almost always happens.
I put an arrow here, but I'm not sure. I'll be honest, I'm looking at gut feeling here.
Right. Okay. So let me tell you a few things. In a connected mass, you have more than one mass, right? You have.
Yeah.
Obviously, you can have 3 masses, right? And also, you can sometimes have the pulley mass, the two connected mass by pulley. So let's say one go up, one go down, or one go left, one go down. You certainly remember those pictures, no? No.
Yeah,
right. Okay. So those are the type of question that will be treated the same, like question 5. Okay. So our discussion applies to all of them. You should expect them to happen all the time in question 5 or question 6. That's how predictable things are. Okay, now let's talk about the connected mass in the example. Sorry, I'm finding my pen. Sorry, but so the last week's check. Okay, good. Now, I imply that you need to think about action reaction in the lift question. Okay. Now, let me break down action reaction to you very easily. Yeah? I push you, you push me. I pull you, you pull me. That's it, Lo? Right? Do I have to be in contact with you to push you or pull you?
Yes, I mean
only in question 4 and 5.
Yeah.
When you go to gravity and electric field and magnetic field, no lah. Action reaction still happen at that point, but you don't have to be in contact. But in this case, makes it very easy. We have to be in contact to push or pull. So you think about this situation carefully. F is pulling 3 kg. That's the first thing you think about. I suddenly collapse the question into a simple mass. I can do that. I should do that. So far, so good?
Yep.
Right. Look at what I get here. I get the acceleration. Oh, wow. I have to think about acceleration. Same thing as question 3. You fail to do that in question 4. That's why you're wrong. Okay. Now, acceleration in question 5. What is the acceleration in question 5?
F443.
That's it. Good. Good. Now, this acceleration, do we have to differentiate between the acceleration experienced by the first guy and the second guy? Do we have to do that?
Yes, because
no. That's the first thing that I notice people don't understand. This A will be equivalent to A1 equivalent to A2. That's how the connected mass work. Their acceleration is the same. How do I know? How do you know?
Because of the string?
No. If you're going to pull this, do you ever see them get closer or get further?
No.
Question 3 tells you, right? Same acceleration, the distance never change. Correct or not? Yeah. Question 3 tells you without the string. If my acceleration with you is the same, my distance with you will never change. This seems too heavy to use it. Right. Everything is new, isn't it? Everything is new. All right. Please expect that things will be lighter next time, but it's very heavy right now. Okay, good luck. Good for you. Right? It's holiday. It's good for things to be heavy. So have you ever seen this guy and this guy get closer or further? You say no, right? So the acceleration must be the same.
All right.
So this is the expectation you need to have in connected math questions. Question 3, question 4, and question 5, you need to think about acceleration. Okay, yeah? Now, since I have A1 and A2 and they are the same, I can now focus on the separate guys. This is 2 kg and this is 1 kg, correct? What's the acceleration of 2 kg?
Acceleration of 2 kg is like, I guess, F/2.
F over, why are you, oh my goodness, things are heavy until you forget.
F/3.
My goodness, right? Things are too heavy until you forget what we discussed 5 seconds ago. Are you sure you can handle it? Why is the acceleration of 2 kg F/3? Why?
Because acceleration is the same.
And why is acceleration the same? How do we know?
Because they don't like get closer or further apart. They just like go.
See? The reasoning is like you seem to expect the reason. You seem to accept the reasoning. Right? It seems to make sense. Right? So use it. Right? So if the acceleration is F equals to 3, and by the way, acceleration has direction. So what direction?
To the right.
Right. Now you see this as F. Make sense or not? No. F divided by 2 is not F/3.
Oh, there's no.
There is an, so to speak, an extra F here. Why? No surprises, no surprises, because there is a string there tied to 1 kg. Remember, the 2 kg is pulling the 1 kg to the right. So what does the 1 kg do?
Pull the 2 kg to the left.
Ta-da! That's why it's not F/2. Wait, that makes sense, right? If it is supposed to be F/2, I mean, if this is F/3, it's smaller than F/2. Wait, that makes sense. Understand?
Find
this guy. Find this guy.
I mean, 2F.
You cannot find that guy. You cannot find that guy, right? F/2 is not the acceleration. It's F/3. Oh, F/3 is smaller than F/2. This guy must exist. No.
Okay.
Right. This guy must exist, right?
So the resultant force is.
Yeah. The resultant force is The resultant force.
F is 2F/3, right?
2F. Why is it 2F/3? Sorry. How did you get that?
Mass times acceleration, right?
Mass times acceleration. Yeah. Correct. Yeah. Sure.
So it means if F the driving force. If F
write something on paper, right? Like simple formula. Right? You need to be very clear on which block are you talking about. Yeah, you need to be very clear, right? Yeah. So okay, sure. The answer is that sure.
So F. I don't know what to call this.
No. Okay. You have a bad habit of calling the tension F. Yeah? I think it's easier to call it T. Yeah, T better, or FT lah. I think FT. Yeah. Call it FT is fine. So in your original arrow, you should call it FT lah. Yeah, or T lah better. So, all right. Good. Yeah. Good.
Boy.
What are you talking about?
F minus 2F/3 is.
Oh, you're absolutely correct. I like it because I thought you make the jump. Good. So you're saying that this is F/3. Oh, sorry. You're saying that this is. I'm so sorry. I have to leave. So you're saying that the guy pulling the 2 kg is F/3. So look at now the 1 kg just to check our answer. In our 1 kg block, what's happening?
F/3 acceleration.
right? So the acceleration is supposed to be F over 3, supposedly, right? Supposed to be. And the guy pulling him to the right is
F over 3.
right, because action reaction. Wait, does that make sense?
I think it does.
Because F over 3 divided by 1 is F over 3. Right? So it makes sense. It makes sense. It makes sense. All this makes sense. Everything makes sense at one go. It's not just one thing makes sense. So if you consider the whole thing as a combination, you get this, and then you consider both separately, everything makes sense. Therefore, your answer is not B lah. Is this new?
Yeah.
I guarantee you that you will benefit from this again and again and again and again and again. So what should you do right now?
Write some stuff down.
Yeah, carry over the expectation. Carry over the expectation.
All right.
Now, the question 4, I did tell you, you do not concentrate on the acceleration enough. So I'm basically saying question 3, 4, 5 are all acceleration. Acceleration is in question 3, 4, 5. So expect that the revision kind of helps you with that. That will be the expectation. So we have 5 more minutes. We have question 6, right? So question 6 is what topic?
Momentum.
Another heavy topic, right?
Yeah.
Imagine that in the MCQ paper, they hit you with question 3, 4, 5, 6. Right? Imagine that, look. And then your school comes in. Your school tends to be, half crazy kind of question, like half crazy school, right? Like kind of pushing the boundary all the time, like only slightly better than RI or ACI, slightly better, only slightly better, right? About the same amount of mercy, I would say, about the same, not a lot. So pushing the boundary, then it hit you 3, 4, 5, 6. Right? Not the best thing that you want to be hit with early in the paper. No, definitely not. Okay, so what do you think about question 6? Right, please move up a bit.
Okay. I think about question 6.
Can you do something about it? Can you do a first step?
I suppose there's not much acceleration here, is there? I'll draw something, I guess.
Sure. Drawing is a good thing. Yeah, sure. Drawing is good.
So hit it. I've forgotten what collides elastically means.
Question mark? In case we don't have the time, your expectation is that your revision will tell you, right?
It goes with some velocity, right? But I don't know if this one goes left or right.
Question mark? Question mark? Sure, question mark. Yeah, so you do not know how to decide on the velocity of the first guy. I think that's a good. Reservation. Good. You don't just assume something. For this one, I think that's a good thing. Anything else that you can do?
I remember there's a formula, but I don't remember how to apply it or what it is.
So are you talking about the elastically collision, or you're talking about something else?
Like M1, U1, or like
All right, so I'm going to summarize the first guy to you, not the elastic one. Huh? So the first guy is very simple. Summation of momentum is the same before and after. Like the momentum doesn't change. The total momentum doesn't change before and after. Now, do you understand my phrasing first? Total momentum doesn't change before and after.
Total momentum doesn't change.
Before and after.
Conservation momentum.
Right. Before that, conservation, precisely lah. You don't need to memorize the formula for the first one. You just have to understand, oh, conservation of momentum. You can write something, I guarantee you lah. I guarantee you. And you don't have it here anyway. You don't have it in the, so you know lah. Before that, I want to mention something else. Momentum is a vector. Why am I saying that to you?
Because it can go left or right. Whereas the negative is the signifier of the opposite direction.
When you total the momentum, does it matter or not?
When I total the momentum, no, it does not.
See how this goes. Because as far as we can tell, when you total forces, the direction matter.
Oh my god, cos equals 0.
Like, I mean, when you total when you summation forces, the direction matter, right?
Yeah, because the summation is to be 0 for force. Oh my god.
If it is equilibrium, right? So then it's it's almost like you never understood this. It almost feels like that. But you did it before, you're just realizing. You need to realize this right now. Would you please write it down, please? Direction matter means what, right? Like means to me, it means like force to me lah. Means something like that. So better pay attention to that lah. Better pay attention to that in momentum. Right. So now for your drawing is excellent. Yeah? So before you have a simplification, right? Before something is 0, right? For the before one. Who is 0?
For M. For M is 0.
For M is 0. So oh, M2 lah. Sorry, yeah, for M. So just this gone lah. They just gone. Okay, right? So you put in the M and the U, right? You put in the M and the U, and then equals to something that you can do first, right? You need to M. Then you have to say V1 no, because you do not know what V1 is, and then plus. Frankly speaking, you also do not know what's V2 lah. Frankly speaking lah. Right? Your expectation is that V2 will be positive, and your expectation that V1 later will be negative. That's the only expectation you have right now.
Yeah.
Okay. Now, how many unknowns are here?
2 unknowns. Well,
let me see. So the question doesn't count U, right? The U that is not considered unknown because they accept in terms of U, right? So U doesn't matter. I don't think the M matters also. So yeah, you only have V1 and V2 to worry about. Now, this explains why you need the elastic collision one. Okay, so look, the momentum one is total momentum remains the same. Elastic one, total elastic energy remains the same. That's it. Oh, I'm sorry, total kinetic energy what I'm talking about. There is no spring here, right? There's no spring here. There is no elasticity here. But colliding elastically simply means no kinetic energy is lost. No kinetic energy is lost. If that's what it means, that means, oh, the kinetic energy total is the same.
So half mv square.
Yeah. Just in half mv square plus half mv square equals to half mv square plus mv square. Same thing lah. Kindly simplify method quickly, please. This is an expectation. expect that the kinetic energy equation you will simplify immediately before even doing anything else. You're not greedy enough. Simplify more, please. You're not greedy enough. Simplify more. You're simplifying the half. Just scratch the.
Simplify n as well.
Yeah. Just scratch lah. You be greedy lah. Be greedy. Okay. Ainesh, I can see you. Yeah. Okay. I'm just waiting for your. Yeah. Okay. I can see you. Your video. So on the topic, you should be simplifying the first guy also. Look.
This one. So.
Right. So just scratch. Okay. You can write down also fine. Okay, now I declare that you only have algebra left. So no longer there's physics. No? Physics is done. No? Right? You can leave here, can stop here and move on and wait for the revision to clear for you. Okay, just do. That's up to you. Okay. I'll be with Ainesh for a while. If you decide to continue, I'll just follow you until the end. Okay, Ainesh, any updates before we start?
Yes.
Give me the updates, please.
Okay, so I was during class and she's really fast, so I try to take them as much as I can.
The function, you mean, yeah? The function.
Yeah.
All right, okay.
So there's a lot of things, weird stuff. So I'm supposed to write it like this.
Show me your confusion. Let me just understand them a bit.
It's not really confusion, just a bunch of new things I learned. Okay, so in order to draw the graph, I should have 3 points, which is the meeting of the x and y axis. I forgot the name of this thing. Asymptote. Yeah. And the point that they give us.
Yeah. Okay, understood.
According to the difference in the equation from y equals to x.
Correct. Understand. Okay. You are confused about this line and point thingy lah.
Not confused. I'm just showing that I learned this.
Oh, sure thing. All right. And then?
Then after that, there's another one.
Yankeen, do some algebra, please. No longer physics, but do some algebra, right?
Algebra? Oh.
No. I'm talking to your senior Yankeen. Right. Okay. Then example 5. Yeah.
So yeah, over here it's very weird. We have to do the opposite.
Let me explain that. Yeah. Let me explain that. Understood.
Yeah, I kind of understand. It's just really weird.
The weirdness feeling that you had since you discussed the x-axis. Like that's the weird feeling that you have, because you will notice that no. So I'm just saying that's the same weird feeling, right? Yeah, so the weird feeling is consistent. You're saying, sorry?
Yeah. Because I feel like I don't have nearly enough practice.
To get rid of some of the weird feeling, maybe let's call it that way. Fine. Okay. Anything else? This is the end of your note.
Yeah, that's what we've done so far. That was all in one lesson.
And it's a double dose of weirdness. And then you have your final exercise. Is it something like that?
No, we haven't done that yet. That's going to be on Tuesday.
Let me see your final page. I'm looking for opportunity to
practices. This is optional homework. We could do this, but I think it's too hard.
No, we should use this to clarify your weirdness, your fearness feeling. At the same time, just whack the homework lah. Right? I mean, better do this homework rather than me giving you another homework, right? I think that makes no sense.
Yeah, you can take a screenshot of this and then put in the Jamboard.
That's very nice now. You cannot zoom in.
Yeah.
Every time I take a screenshot, it's not nice. So you bear with me lah. So you just tell me when things are blurred lah. You just have to live with that. Just have to live with that. Right. Okay. So done. Now, any other updates?
I thought we were gonna. I think like what? Okay. So when are we doing the tuition on Monday?
Good question, which is tomorrow. Same thing. I told you. Nighttime is always better. As in always guaranteed. But if I can somehow do it at afternoon, I'll tell you at the moment notice lah. So it's not gonna be something I can answer now because it's hour by hour thing, baby stuff lah. Okay.
Yeah.
Okay, is that okay with you?
Okay, I was doing the 1.5 hour session.
Yeah, 1.5 hours is fine. For you, I think longer, not so good. So that's the maximum.
Yeah. Okay.
Mhm.
Okay, I'll let you know as well because I might have to go out to do a project. So
let's just say that even if I can afternoon and if you cannot, nothing changes, right? We just do it at night.
no, I think.
What do you mean?
Okay, as long as you give me an hour's notice beforehand, I think I can get back and home at time. Cause I'm not going that far.
But that means that you have to stop your project work together. What? That doesn't make sense.
That's fine.
Are you sure?
Yeah.
Why don't you just plan your project work in the afternoon? Doesn't it work that way? Let's just just decide. We do it at night for tuition.
Okay, sure. Then we'll do it at the regular time, like today's time, 7:30.
Right. Do you want to message your friend first?
Sure.
Yeah, just settle that one first. Just settle.
Okay.
Like, so I suppose, Yankeen, that's the worst thing you can do, but
Yeah.
why don't you do it? I mean, why don't you just whack? Why don't you just wait?
It gives me something very sure.
Oi, what are you talking about? How do you get the 16v2 square? How did you get that?
I just squared this.
Oh, you nonsense. You mess up your algebra. You're a senior. Don't mess up your algebra like that. That's unacceptable. Your math is better than this.
My bad.
Yes, that's very bad.
Yeah, so I was wondering why I had something.
Hey, if algebra is that easy, then you don't have to learn algebra, right?
Yeah.
Come on. Okay, much better. Okay, again, cancel judiciously, right? You don't use cancellation a lot, isn't it? Okay, fine. You can do it in your mind. That's okay, I suppose. Okay. Good.
Wait, I'm trying to find V. I suppose it doesn't matter.
No, yeah, you can just return back to it later. Doesn't you don't have to stop. Yeah. Cancel judiciously, please.
So
Ainesh, tell me when you're back, yeah?
Yeah, I'm back here.
Yeah. Okay. Tell me when you're done, yeah? So I simplify judiciously, Yankeen. Come on.
Yeah.
This is math.
12 over 8 is in my head 3/2.
Right. So you got something, and I think this something is useful. Definitely useful. Right. So what do you do?
I mean, I guess I just plug it into the equation, right? So
yeah, up to you. Yeah. And the first equation is easier, right? First equation is easier than the second one. You're a bit nonsensical. You are a bit nonsensical.
What?
You're a bit nonsensical. You're not reading the question again. I'm a bit surprised that you have problem reading the question. I'm a bit surprised. Question 3, same problem. Question 6, also a problem. You're doing everything correct. What is the velocity of the molecule of mass m after the collision? And you go and eliminate the v1.
Oh,
nonsense, right? Just
I'm
creating
looking
more
for v1.
Yeah. Don't eliminate v1, don't, right? Yeah. I mean, this is not okay. That's not okay. Reading question is supposed to be your forte. Like reading is supposed to be your forte, right? Okay, please do that, Please do that.
So I need to change 4v2 into.
Yeah, just flip the v2 to v1, Just change the subject, basically, right? Math. V2 equal to something V1, right? Because you want to eliminate V2. It's not that difficult, right? Okay.
Divide by.
Okay, Ainesh, are you there? Good.
Yeah.
Okay, good. Right. Okay. So back to the question. So let's go to the weirdness thing first, and we'll do the question as it. So which part that you find weird and you want to ask question? This is the first time I receive a direct question from you from the class. So I'm looking forward to it.
Okay.
Previously, there is no, this is the first time it happens in our, 10 to 12 tuition. So I'm looking forward. Huh?
Okay. So obviously the very obvious one. Is this just memorization, or is there a logic behind why we have to address the addition and multiplication of x first, then multiplication and addition of the fx? Okay,
then let me explain this. Because they say AMMA, right? So if you do MAAM, meaning to say if you do the fx first, MA, and then you do the x first AM, it doesn't matter. You want to try? You try immediately. You try right now. Try doing the fx first, MA, and then you do the x, AM. It'll be the same one, right?
Okay.
So that you can clear this down. It's a good question. It is a good question.
Yeah.
I missed something.
No, that seems fine with me. What do you mean? It seems fine with me.
So that's negative a over 3. So
it's negative, right?
Be,
it's negative,
yeah.
Right? Negative, right? Yeah, okay. Then it should be.
Negative 5.
Yeah, I know. U is negative 5 over 3 V1, right? Again, if you're complaining here, your reading is not activated. I still don't know how to talk about this to you, but your reading is like standard in physics. Your reading is supposed to be very good. Like you're confused over something which you don't have to be confused.
So there's no recipe.
Read the question. What is the
velocity of
the molecule of the mass m, right? You're reading that, right? So this velocity is v1, right?
Yeah. So
Ainesh, are you okay? Sorry, are you stuck, Ainesh?
Yeah, I was doing because so you mean changing of the entire process, like anything random, or
no. Let's take the point 3,6, right? So let's start from 3,6. So write down 3,6.
Yeah.
Now instead of focusing on the x, you're going to focus on the y because that's what fx means. Yankeen, you okay, right? Okay.
Yeah, I got it already.
Right. Yeah, so you're reading, okay? You're reading. Right?
Yeah,
so,
no.
6 MA lo. So do MA6 for Ainesh. MA. Now at this point, Yankeen, you can continue by yourself if you want to, and you have some expectation about the revision already. Okay, good. I'll see you on Tuesday. Yeah,
okay.
Right. Bye-bye.
Thank you. Bye-bye.
So Ainesh, MA for FX. The multiplication for fx. What is the multiplication for fx? Oh, you don't see it. You don't see it directly, isn't it? 1 minus f 2x. What is the multiplication for fx?
Oh, it's minus.
Good. So what happens to the 3? Nothing. What happens to the 6?
Nothing.
No, minus 6. Yeah, minus 6. Simple, right? So it becomes this one is the no. That's modifying the x. I'm asking you to modify the fx first.
Oh, then
y equals to minus fx. All right. So then,
why are we doing that?
Because your question is the order memorization or not? Why do we have to concentrate on the x first and then the fx? That's your question. What?
Okay.
So my answer is no. You don't have to.
Doesn't reach the formula. The formula is 3f 2 minus x, right? How does it reach that?
Oh my goodness! I thought you're talking about the question above. I'm very confused. Yeah, I thought you're talking about this.
My bad.
Okay. Yeah, because it's very confusing. Okay, 3f by 2 minus x, and then take 1 point from there. Take the point. Take the second point. What's the second point? 3,6 also. The second point is also 3,6. Okay, good. So 3,6.
Yeah. Okay.
Again, let's go to 3,6, and then your multiplication for f is 3, right?
Yeah.
Yeah. So 3fx. 3fx. Good. Start from there.
Okay. So
As you can, yes, 3fx, right? 3fx. Got it. Right. So do something to the coordinate.
Sorry. We
Wait, why are we confused? Yes, yes. Who?
The 6.
Good. Okay, good. This much makes sense, right? I'm not asking you to memorize it. This much does make sense, right?
Yes.
Okay. Then M and then A lah. So any addition for the fx?
No.
No. So how does your teacher want you to write out? Does it still want you to write down that? Okay, there is no change. Okay, then you can skip that.
Write down this.
Okay. So you can skip the A lah, correct?
Yeah.
You can. Okay, then we go to AM for the X lah, right? Okay, so go ahead. The AM for the X. So first the A lah. So what's the A? The A is
+2. I
agree. So go ahead, write that down. 3f x plus 2. Great. So what do you do to the 18?
16.
No, you do nothing to the 18. I'm trying to confuse you here. Right?
Yeah,
okay, so you do nothing. Good. What do you do to the 3 then?
1.
Very good. -2. Good. So write down 1, 18. Right. Then the last thing lah. Good. Now they have a tendency to call y as fx lah. Don't ask me why, but just the thing lah.
Yeah.
Okay. Good. Then continue. Then the multiplication of x, right?
Yeah. So it should be
totally fine. Good. So what do you do to the 18?
Wait, what?
What do you do to the 18?
Oh, okay. What do I do to the 18?
Yes.
What do I do? Do I make it -18?
I'm trying to confuse you, Ainesh. Come on. I'm trying to confuse you. What do you do to the 18?
It's -1.
Yeah. So what do you do to the 18? Nothing.
Nothing. Yeah. Okay.
Good. You should be saying that to yourself. Nothing. It's nothing. No, I'm not concerned with 18. So do -1 lah. Go ahead. So kindly check whether this is the same answer. Voila.
Yes, it is. Let's go.
Good. Okay. So what I'm trying to say to you is this: whether you do y first or x first doesn't matter. The package inside the y is what matters. You have to do YMA, and then you have to do XAM. And I will argue that MA makes sense. Not make sense, sorry. It doesn't feel weird. It's the same thing. The X will feel weird. I wish the X is also MA, but no, the X has to go out of his way and flip the order to AM.
Yeah.
Okay, so between AM and MA, the only weird guy is X. Same thing.
Yeah.
Right. So have I answered your question?
Yeah.
Do you want to do one more time for the other guy, just to be sure? Right. So the other question.
Yeah, I should get some food.
Oh, sure. Do as you wish. I go to the toilet.
Yeah.
Are you okay, Ainesh?
Oh yeah, okay.
Right.
Okay. So, what point should I use?
That's up to you. I think maybe the more difficult one. So again, 3,6.
Oh, you have a different formula? Okay.
Because for some reason it's the same point, right? Same point, right?
Yeah.
Same graph, right? Same graph.
Okay. And 3,6. So should I do A and MA?
No lah. If you do MMA, that's the same thing as what your teacher is doing.
Okay. So I'll
Right?
do
Do
MA.
MA lah. Do Y first and then X lah. So let's see what happened, right? That's what you want, right?
Yeah. Okay. So first I multiply fx. Nothing happens when it gets minus, so it reflects.
Sorry, you're saying?
Y equals fx, I need to multiply it first, right? So nothing happens, but it gets minus, so it reflects.
Yeah,
correct?
yeah, that counts. Yep, yep. So you write down. Yeah, yeah, good, good. Yeah, yeah, yeah.
So then it becomes 3 minus 6. Correct?
Give it a try first lah. Give it a try first lah. Try first. I mean, you have sufficient understanding, Ainesh. You don't have to rely on me too much. Try first, overcoming your sense, right? So go ahead, write something, right? Okay, good. Yeah, okay. Okay. Yeah. Yeah. Right.
Plus minus 7 and minus 5.
Yeah, I don't think adding is the proper word. I think you should say move up or down. I think that makes more sense.
Okay.
Adding doesn't tell you anything about the movement. So what are you trying to do with +1? The y is +1. So you're saying what? Moving what? Okay, moving up. Okay, okay, good. So moving up -6 by 1. So what does it become?
Minus 5.
You see what I mean? That's a better way of saying it, right? Okay.
Okay.
Okay, sure.
So 6 minus 5.
You forget the weirdness of x.
Oh,
you forget the weirdness of x. You forget the never forget the weirdness of x. Never.
Yeah.
Never forget the weirdness of x. Never. Never. It's called shrinking, right? So you should have shrunk it. Right?
Yeah.
Right. I agree that that boils down to memorizing a bit. So it's like the practice is supposed to help you, fix that in your mind. Like weird, x is weird, x is weird, y is not, y is not. But that's all. That's really all.
Yeah.
Now, I am very happy to answer a question that comes from your class, right? Very happy.
Yeah.
Last time I keep asking you and you cannot give that, right? So this is very good. Anything else I can help you for this page first?
No.
Right. I think we have covered everything also lah. So I'm quite happy also, right? Okay. As for the drawing, I will leave it to you lah because I have never seen you draw. I suppose I'll see you later lah next when you do the homework. Okay.
Sure.
Okay. Good. If it's okay, then let's move to the next page because you say there's something else weird here.
But this whole thing is a different concept. I mean, not different. It's just tested to the next level because you got to inverse everything.
Right. Now, this is the minimum you need to achieve, not the maximum. There is more, but this is the minimum. So let's talk about this. Huh? The minimum you have to do for exam.
Oh, wait. One second. Before you start on this, I need to cover a few more topics first. This Thursday.
What did you say?
Hello? Is my mic cut off?
No, now it's here. Now it's okay. What is it?
So basically, before we start on this, let me say something. So this Thursday, we are redoing the media test. Like a mock paper.
Okay.
On the thing.
Sure. That's the last day, is it? Last day of last day of school, kind of ish.
Technically second last, but I'm skipping Friday, so yeah, it's last for me.
Why are you skipping Friday?
I'm going overseas that day.
Right. Okay. Can't wait. Good. So, but I don't think that changes anything. I don't want to deal with exam if you can let it go.
I understand, but
how do you feel about it? This is a feeling thing. How do you feel?
Nothing. I haven't even looked at the paper yet.
So we're repeating the topics, right? We're repeating the topics. Huh?
Yeah, those topics, like it's the exact same question. She's just testing understanding.
Exact same question.
Yeah.
Then you don't need my help, huh? Or rather, do you need my help?
I mean, I need it, but I'm not going to take it for this test. But I do need to cover the topics that we haven't learned yet during the June holidays, if possible.
But we always prioritize and give time to the future topic first.
Yes.
And then we use the remaining time to cover, I don't know, maybe 2 topics. That's the most we can do. But we cover the 2 topics properly. Because you must understand one thing. After we cover the topic, if I don't give you practice, there is no point.
Yeah.
And when you go back to school, you'll not be practicing those topics. You'll be practicing the future topics.
Yeah.
So I have to give you additional homework not related to the future topic. Some students cannot handle that.
No, that's what I'm saying we should do in the holidays, because once the school starts, I'll be overwhelmed with schoolwork and coursework.
Fair. So we do what we can, but trust me on this. This is the best way. It's not about catching up first. It's about future topic first.
Yeah.
Right? You trust me on that. So again, back to this example 5. So if you could tell me what's confusing, if not, I'll just jump directly to it.
Okay. I still don't visually get the stretching and shrinking, because like I said, my visualization is really bad.
Fair enough. So the wording of stretching is here. So in some sense, this question is better than the previous question, because the previous one, we have to figure it out, right? Like what's going on here, right? Okay. Yeah. So they even tell you the sequence. So we don't even have to think about sequence. So first thing first, we don't have to think about what it means. They already tell us. We don't even have to think about the sequence. They tell us. We just have to draw it basically, something like that. No, I'm sorry, not drawing. You're not supposed to draw it. You cannot draw anything, right? You cannot draw anything. You have to work out the original curve. That is the most challenging thing ever. That's the most challenging ever. Now, let me clarify a few things first. Because you're working backward, do you understand that this question asks you to work backward?
Yeah.
Okay. If you're working backward, then it makes sense to go from DCBA.
Yeah.
Right. Secondly, it makes sense if you say stretch, then I'm supposed to shrink. If you say reflection, then I still reflect back. That one doesn't change one. That one never change one. Reflecting back is just a reflection. But stretching will become shrinking, right? And then, okay, I'm sorry, D say stretching by a factor of 1/3. Basically, that's shrinking. That's a bit annoying, but that's a proper way of saying it.
Yeah.
So I'm stretching by 1/3, or I'm shrinking. Oh, then I'm supposed to stretch by 3. Then you put it correctly. Right? And then the B is also the same thing. You have to say, actually you're shrinking. Okay, then I'm supposed to stretch back, right? Stretch back by 3. And then translation by a magnitude of 1. Okay, let's talk about what 102. Let's talk about C first. I'm so sorry. Reflection in the x-axis. You reflect back in the x-axis. What you're saying doesn't make sense.
It's on the y-axis.
Yeah, the y-axis is totally wrong. Let me show you why. So let's get this visual. Let's just clarify this. So in the Jamboard, page 17, are you there?
Yeah, it is.
Right. So let me talk about C. C.
No, I understand why it's x-axis.
Oh, okay. So x-axis, then go back x-axis. That's all the same. We're just going back, right? Okay. Now the A, same thing. So the 1, 0. So teacher already covered what the this strange format 1, 0 means. What does 1, 0 mean?
Teacher didn't really cover it, but it means that the 1 is x and the 0 is y.
Correct. So the +1 refers to the fact that you move to the right. So in your working backward, you should say moving to the left.
Oh.
If that makes sense. Again, we're just working backward. We're just working backwards.
Wait, no, it should be moving to the
let me think for what?
It should be moving to the right. Yeah, that's right.
Oh yeah, that's the format that they do. I'm sorry. Let me clarify this.
This translates, right? So this 1 means that you're adding a value and x is inverse, so it moves to the left. And now you're reverting it back to the right.
You're absolutely right. So you're absolutely right. Absolutely right. Sorry, I forget about the format.
Yeah.
Okay. So the DCBA working backward, blah blah blah, is already good, right? Good, yeah. So we start from the result 1 plus blah blah, and shrinking by 3. I agree it should be divided by 3. So you're correct,
Yeah.
The first guy is correct. The second guy is.
I'm pretty sure this is all correct because I just took this down from class. I'm pretty sure.
Oh, I'm sorry. Obviously, the reflection in the x-axis, you minus the y. Absolutely correct. I'm sorry. Absolutely correct. That's absolutely correct. And then, because stretching by a factor of 3, that will be actually times 1. Oh my goodness. Then you have to talk about the confusion caused by this. Because, oh no, you have to talk about it. No, oh my goodness. So finally. I talked to you about this weirdness of x, the first time. I tell you that the y is also weird, but the weirdness is it's not apparent, right? I did tell you something like that. So now watch how the question worked it out, right? So you already determined that I should be you should be stretching, not shrinking. So you don't say vertical shrink, you just say vertical stretch by a factor of 3. You're basically stretching, correct? Correct or not? D is you're just stretching by a factor of 3. Now, how come y not supposed to be weird, but now y treats himself as if he is weird? It's divided by 3. You're supposed to stretch by 3. He's dividing it by 3. If you don't think that's confusing, then we go. If you think that's confusing, we talk about it.
There's a vertical shrink by stretch factor 3. Basically,
don't say vertical shrink. No. It is a stretch.
Yeah, I know.
It's not a vertical shrink. Would you please cancel the wording string? Sorry. Just vertical stretch by a factor of 3 is enough, right? Just enough. Don't say shrink. Don't. Same thing with the horizontal guy. It's just a stretch by a factor of 3. Don't say shrink, yeah? So I'm supposed to stretch the y by 3. Why am I not 3 times y?
Yeah, why?
Okay. So going back. So I'm going back to the first thing I told you. Now give me a simple formula. Simple equation.
Y equals to fx plus 1.
I'll take it as x plus 1. Okay. Excellent. Right. Excellent. Right. So
Jamboard?
Jamboard, page 70.
Yeah, I'm on the Jamboard.
Oh, this thing will not. Okay, so I'm going to put x squared plus 1. X squared.
Oh, I just realized you can't see.
Okay, so can you see the Jamboard in page 70?
Yeah.
Okay, right. So my fx is now x squared plus 1, right? Okay, so now I'm going to 3 times fx. So what happens with 3 times fx? I'm going to stretch it, right? 3 times fx means is 3 of x squared plus 1, correct?
Mm-hmm.
Okay, now let's call this the new y. No? So not to be clear, this is your new y. I'm sorry. Yeah, correct. I'm just calling it right. So now x squared plus 1 equals to y over 3. Right. So look at 3 times this is stretching the y. Okay, 3 times this is stretching the y by 3. But the same thing happens here. If I divide the y by 3, I'm also stretching it by 3. Is this confusing or not?
I mean, I don't see the way you showed it to me, but I can understand because you're doing the entire question inversely, so everything should be the opposite.
Correct. So look at what happened in your question. So in your first line, y divided by 3, but the moment afterwards is everything on the right times 3. 3 times fx.
Not really. For example, x actually goes the right way now.
No, x doesn't go the right. No. What? No.
X goes. I mean, if you're looking at it at a non-inverse point of view, and you're looking at it just a simple equation that you're doing, y is actually just doing the opposite of what it's supposed to do, and same for x.
No, x is not. X is still have to be stretched by a factor of 3. So x over 3. It's still weird.
No, like over here when you're affecting fx, and then when you're affecting x, they're both doing the opposite of what they're supposed to do.
No, x is not. S is supposed to be stretched, and it is x divided by 3. So when you stretch x, you're supposed to divide it by 3. What? The weird guy lah, the weird thing lah. Right? No? X over 3? Like, why do you x over 3? Because you're supposed to stretch it by 3. Okay, that's the same weirdness we have been dealing with all the time.
Oh, okay, now I don't understand.
Right, okay, back to y. Okay, back to y. So back to y first. So y is now being weird. We agree on that, right? Y is now being weird. But it's not, because 3fx, 3 times fx, if I move the 3 to the y side, it's y divided by 3. That's the hidden weirdness of y. If you deal with y directly, you have to accept the fact that I have to divide the 3 here in order to move it here and times 3 here. This is what you're used to, 3 times fx. But if you move to the y side, it's y divided by 3. Am I making any sense here? Sorry, am I making any sense here?
No.
Okay,
why is no? Why is this becoming this? Where is the 3 coming from?
Oh, because again, the wording says I'm supposed to stretch. Okay, I forgot to write the wording. So stretch what? Stretch the y, right? By a factor of 3. Stretch the y-axis. Stretch the vertical axis, whatever. That's the vertical axis by a factor of 3. Oh, right. So I just 3 times that factor. Correct, right? Normal stuff lah. But remember, 3 times fx is, if you move the 3 to the right, it is the same as y divided by 3. Okay, so now I'm going to copy your working. I'm going to copy your working from class, and I'm going to do something that hopefully makes sense, right? So I'm going to do that. Right. For some reason, I'm seeing it more clearly. I like it.
Are you? Oh, there you go.
For some reason, things are getting clearer. I like it. Now, I'm going to do something that makes it feel better for you. This is feeling. This is really feeling. This is your feeling in question. So I am going to cancel that. Okay. Instead, I am going to do this. 3 times fx, right? That's what I'm supposed to do, right? 3 times fx, correct? That's the non-weird y, correct?
Yeah.
So voila, I did that. So look. From this to that. This is 3 times that. See, I'm supposed to do that. This is the y not being weird, the fx not being weird. Correct or not?
Okay.
You don't sound happy.
Yeah. I do.
Try canceling this. Try just canceling all this. Try just canceling all this. And remember that this is fx. No? So 3fx, right? You're supposed to stretch the vertical by 3fx, done. Finish one. Maybe you put the arrow on the right hand side because the fx is on the right hand side. Maybe just do that. Maybe it's easier to see that way. This guy is fx. This guy is fx. So 3fx then. Three times that. So 3 bracket everything like that. Yeah, okay, sure. You can do it directly. Or 3 bracket that is probably easier to see.
Yeah.
So this is your 3 times fx, the non-weird stuff. There you go. You will get the same answer with your teacher.
Okay.
You don't have to follow your teacher strictly on this method. You can just do the way you used to do it, and you'll be fine.
Okay, I see you now.
Right. So is this answering your worries lah?
Yeah, kind of. Okay.
So why doesn't have to be weird lah? Is all I'm trying to say. Why doesn't have to be?
Okay, I'm going to put one of your.
Sure.
Thanks. Okay.
Okay, yeah, I got something to fill my stomach. So, right, are we ready to do the homework.
Okay, sure.
Right, give it a try. Now, I'm going to classify to three things. So the first type of question is the super basic one. So that means the one before the sequence. So there is no sequence. The second one is the one with sequence. So you have more than, one transformation. The third one is the one working backwards. The one working backward is the one that we faced just now. The three basic categories. Okay?
Okay.
Now, question number one, exercise A, B, C. Is this one transformation or sequence or working backward?
What's going on? There's like modulus and powers and stuff.
I'm sorry. Yeah, sorry. Yes.
What's the modulus and powers and stuff?
My goodness. Let's forget modulus for now. Oh my goodness. Everything you see here is not, it's not what you usually face, and that will scare us, right? It doesn't matter. It doesn't matter. Doesn't matter. The modulus doesn't matter. The 1 over in C doesn't matter. The power doesn't matter. I guarantee you it doesn't factor in at all. Let me explain why. Let me explain using the first guy. Let me using the first guy. Identify is basic graph. That phrasing means which one? One transformation, sequence of more than one, or working backward? Which one?
For A?
Oh, A, B, C. Same thing. It's the same question for A, B, C. One transformation, sequence of more than one transformation, or working backwards?
Sequence of more than one transformation.
No, working backwards. Also more than one. Working backwards usually more than one. This is working backward. How do I know?
What?
How do I know that this is working backward? You read your example 5. You read your example 5.
Example 5?
Yeah, example 5. We did it just now. The working backward question. This one is the working backward question, right? So the curve whose equation blah 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 undergoes this following transformation. Given that the equation of the resulting curve is that, right? The resulting curve is that. Find fx. Who is fx? Fx is the original curve.
Yeah.
Right? So result, they give you the result, they ask you for the original. That's not what usually happen, right? So we work backwards now. Look at the exercise 1 now. Go back to the question, exercise now. What they give you in A, is that the resulting or is that the original?
The resulting.
How do we know? Because he asks you to identify the original, the basic graph. Understand? This is working backward.
Oh, okay, got it.
Okay, can ya? So now the basic graph, right? He wants the basic. So it's very weird, He wants you to take the basic graph first before describing the transformation. It's very weird one. So I'm just going to do that exactly. See, I'm going to, out of nowhere, conjure up a basic graph. Fx, the basic Fx is 2 to the power of x. See me doing magical stuff without any reason at all. See that?
Huh?
Yeah. See me doing that. See? This is the basic graph. I give you no explanation. Must be feeling very weird. But now I ask you to describe the series of transformation going from here to here. How do you do that?
Okay, so assuming I use the regular AMMA. So I first affect
So just the AMMA lah. Just use the AMMA. So any A, any M, any M, any A lah, right? So just go AMMA lah.
So I affect X first.
Sure.
So
anything affecting the X?
Plus 3?
Yeah, correct. Plus 3. Correct. Here's the X. You're focusing on X. Here's the X. See, plus 3. Okay, then any M?
Minus.
Yeah, times minus. So good. Okay, times minus. Then any M for the Y?
No.
Yes.
No, minus.
That's minus. Okay, then any A for the y?
Yeah.
Which is?
Pi.
Right. So just to be sure that this is moving to the left, right? Just want to say that. Right? Okay, so if I gave you the basic graph, you can identify this easily, right? Easily, right? But I'm giving you an explanation why I think this is a basic graph. I don't. Okay, now I'm gonna do the same. Now identify what is the possible basic graph for this, like magic. And if you cannot do B, do C first. I don't think C is necessarily harder than B. I don't think so. Okay. You can try which one first, B or C?
I think I'll take down A first.
Sure.
Okay. Then after that, I'll try C because I'm not comfortable with modulus.
Okay, bye modulus. Who cares about modulus? Okay, but C, tell me what's the basic graph, right? Magic, conjure.
Yeah. Actually, you know what? I'll copy this down after lesson, the A. So
yeah, sure. Yeah, save time, save time. Be more efficient, intuition. Good. You're getting it. See, you're getting it. Last time you insist on copying it.
So just as long as you don't remove this, I'll be fine.
The Jamboard is yours. I have no right to remove it. Understand?
Yeah, just like you accidentally rub it away. Okay.
Won't be erasing that. Yeah, I won't be erasing that. So now C, please. Magic. Basic graph. What's the basic graph for C? Magic.
1 by x.
I will agree with you.
Do you agree?
With you? Yeah, I agree. I mean, it's magic, right? But it seems very reasonable to me. Okay. And then you do your AMMA. See whether we can agree on that.
Okay. So 1 by x. So now I add with x plus 2.
Okay.
Adding x is change in the x-axis inverse. Okay.
Yeah, plus 2 means to the left by 2, right?
Yeah.
Which becomes 1 over x plus 2. See, the usual thing that you're doing, right? The usual thing, right? Then
okay, then after that, multiplication there is none. So then after that, multiplication in the y-axis there is. Then after that, there is, okay, so it's a plus 3.
Yeah, and I think we can agree on that.
Yeah.
I leave the English to you, right?
Okay.
Now, let's venture, venture out of our comfort zone into your non-comfort zone, of course, right? Let's imagine the possibilities of B. Magic, conjure. What's the possible basic graph?
Okay, can you quickly give me just what does the modulus do again?
Okay, I'm happy to explain that. That takes like half an hour to explain properly. Now,
what do those lines mean?
I'll give you a better one. Your AMMA never includes modulus, correct? Your AMMA also, if you notice, never includes power and also never includes 1 over x. There is no such transformation for you, correct?
That means modulus.
Yeah, that's it. The one that you never learn, you just whack as the basic law. That's how magic, no more magic. No more. No more. You don't have to worry about it.
Yeah.
Okay, now let's try the AMMA. Nobody is prohibiting you to do MAAM. Nobody yet, but just saying. Sure.
Addition to x, there is none. Actually, I don't know. Is there addition to x? I think there's addition to x.
Yeah, the modulus can be confusing like that. Yeah, but consider in part A, you consider the 3 as x. In part C, you consider the 2 as x. So I think in B, you should consider the 1 as x. I think there is basically I think there is, because that just works like very similarly to A and C.
So addition there is.
I agree that can be a bit confusing. Yes, I agree.
Yeah, actually no, I think I understand it. So there should be +1. But modulus is so hard to write.
Algebraically, it is confusing. I mean, I can understand why you say it's confusing. Yes. Now, is there an M here?
Yes.
Right. The M will be
multiplication.
By,
oh, wow, so much. -2.
Yeah, so that means you will consider this a combo, right? A combo of reflection and shrinking. Do you understand this? The English will be reflect and shrink. I don't know, don't say shrink, just a stretch by a factor of half.
Yeah.
Can you accept this?
Yeah.
Good. Yeah, so both good. Get used to it. This will happen.
Okay, so then there is no multiplication, but there is addition. So addition by 3, which means plus 3y, which comes my final answer.
Right. So you got the basics already. What is not covered in AMMA, you put it in the basic graph. Basically, that's it.
Okay.
Now, would you like to, I think that note is like, oh, I understand the question, right? Oh, that's how the question works, whatever is not AMMA, I put in the basic graph. I noticed that you don't write notes on that. I noticed that you don't write notes on how to deal with certain questions. I noticed that you write notes for the foundation and the basic stuff. Very important.
Yes.
Right? Would you like to write notes for the, how to understand and deal with types of questions? You can write it here. You can write it in exercise 1 here. You don't have to have another piece of paper. This question, this is how you deal with it, or this question is how I would see it. Okay, would you like to do that? Pretty sure it will happen in exam. Pretty sure. Either this or something crazier.
Yeah. I don't mind the notes. I mean, it's probably not extremely accurate. It's just from my understanding.
Yeah. I don't care about the formality of your notes. It is something for you. Yeah. So you understand. I don't even have to understand. I mean, there's some risk to that, but it's for you.
Yeah. Wait, this is 2 to the power of x, right? Yeah.
I would say, yeah, because that is not covered AM, right?
I thought it'd be 1 to the power of x.
1 to the power of x.
And then you multiply it by 2.
You're in this house. No, that's not how. Look, multiplication in this only works when you either have the base or the power the same.
Oh yeah, I forgot about that. Yeah.
Yeah, you cannot just times 2 like that. Your base and power must either be the same.
Yeah.
Right, so remember that.
I need to revise it in this one. Okay.
So if exam gives you something weird, great. That weird thing is the basic function, something like that, right? I mean, the question can give you log. There is no log in AMMA. Oh, the log must be basic law. Right? Okay, hope that makes sense. Now, are we ready to go into question 2? Right, now question 2 is a different type, right? So let's see whether you have covered this type or not. What are three types you learned from your lecture notes? Solo, solo transformation. Not going to happen in exam, right? And
Yeah.
multiple, which means sequence lah. So sequence of multiple transformation, or the third one is what?
Reversal.
Yeah, working backwards. So what is question 2?
What's this? How is that even the asymptote?
I argue that there is an asymptote. I will argue that.
No, the asymptote is for x equals to 0.
I would agree with you. I would agree.
What did you say?
The line y equals. Oh, I mean there are two asymptotes lah. One is the vertical guy and what's the horizontal guy. The horizontal guy is clear lah.
So how does this become an asymptote? I don't get it.
So the weird thing about asymptote is they say you never cross the graph, and here you go. The graph is crossing the asymptote. So annoying, right?
Yeah.
So I apologize lah. The shorter thing I can do right now is to apologize. I apologize how inconsistent math seems to be. The only thing that the graph doesn't cross is this end. This end will never cross the asymptote. So to him at this end, he is an asymptote. But this asymptote doesn't care about this part. I apologize for the inconsistency and the headache that it is causing you. That's the shortest thing I can say. This will happen again and again and again. The asymptote is correct here, no? That's the only defense I can give you.
Okay.
Again, I apologize first for that. Because I want to focus on the transformation, not the asymptote. Okay, back to the question. What type of question is this? Solo, multiple with sequence, working backward. Is it?
Multiple.
Multiple with sequence. Good. So, but you're supposed to draw up. So I think you can do this. Do you have to do it now?
The whole question?
I mean, because it'll take a lot of time. But I think you can do this by yourself.
Yeah, okay. I can do this by myself, but I think it'll take me a long time.
Okay, so why don't you do it, and tomorrow show me at least 2. Please tell me which one you want to show me tomorrow. One, just select the question. Okay, you can change, but select first.
I'll just do this and this because they're too different.
Oh, I agree that part 3 is needs to be discussed. Yeah, I like your selection. Part 3 can be confusing. Good. Okay, moving on to question 3. Okay, what type of question?
Oh, no, time was over.
Sorry, you're saying?
I'm perfectly fine to continue.
I'm sorry, I cannot hear you. Sorry.
The time was over, but I'm perfectly fine to continue.
Yeah, because you're supposed to go to 9 o'clock, 1.5 hours.
Oh, yeah.
Right,
Okay.
remember. Right. So part 3, okay, what is it? Aryan, just telling you that I can see you. Can you hear me, Aryan? Aryan, can you hear me?
Yes.
Okay. Ainesh, feel free. I want you to try question 3. I do want you to try question 3, like right now. Give it a try if you can. Now, Aryan, one question before we start. You will notice that Michael and Noah is not here today. Do you know why?
It's because of the Martang O-level.
Yes, which you not have this week, right?
Yeah.
I still don't mind you not doing tuition today. I'll just push everything back to holiday tuition anyway, so I don't mind, right?
Oh.
So what's happening? Because my suspicion is that for you, nothing is happening except for additional school, right? That's all. So additional school, does it mean additional homework, for example, additional topic?
No, not really. Just gonna go through topics like the topics that are uncovered. Yeah.
Right. So you think about this. So Michael and Noah is obviously not doing that, right? They have to do their mother tongue. Then maybe they will cover new topics, right? But not going to happen for at least 3 days. So it's because you're covering a new topic. It does make sense for you to have a tuition today if we cover the new topics. That's one thing we can do today. What else can we do today?
We just revise old topics.
Not very motivated to do all topics right now, unless there is a specific topic that you have in mind.
Not really a specific topic. Yeah.
Nah, I mean, we will certainly do that in holiday tuition anyway, right? Right. So what's the future topic? Do you know what it is? I mean, integration, right? Integration, what else?
Organic chem, teacher's gonna go through.
Oh, yeah. I don't mind. We can go to Ochem.
This week.
Yeah, Ochem, I don't mind. We can revise it back, right? You have covered at least Alkene, right?
Yeah, not yet.
Oh, you haven't started Ochem?
He's gonna start this week.
Oh, things are going to be very easy for you the first week, man. I mean, that's what you can end. And what I'm saying is that you will enjoy the class. At least I hope so. So we have Ochem, we have integration. Anything else?
Electromagnetism for physics.
Let's not be greedy and focus on math and chem first, then maybe then physics, because I mean that's the original way of
yeah.
Okay, fine. Yes.
I'm not really sure if there's anything else. Yep.
Should be lah, right? There should be lah. So EMAT, you basically finished the vector, right? You finished the vector, right? EMAT.
Yeah.
So basically your EMAT syllabus is done. No? Expected lah.
Yeah, but we haven't really completed the whole vector yet. It's still a bit.
At this point, again, the ground rule, Aryan. I do say, okay, we focus on AMAT and Chem. But if you have an honest question on physics and EMAT, what is honest question? Honest question is you have done the question and you want to ask. That's what honest question means. Understand?
Yeah.
So not like, oh, you have a homework on physics. Okay, let me help you with it. No. You have done it. So you have done EMAT question on vector and you want to ask 1 question, 2 question, 3 question, whatever. As long as you have done it, you can ask. That's the ground rule. Same thing with physics. Understand?
Yeah.
So it's not like you cannot understand physics or ask EMAT, but you have to do it first. Whereas for math and chem, I will usually take initiative to go further or do a harder question, whatever. Okay.
Yeah.
Yeah. Good. So we're going back to math and chem. So my requirement for Ochem is this: if you want to just brush through your Ochem a little bit, we don't have to do a lot. You have to find the summary I tell you last time. You have to find that first.
Yeah.
Right. If you want to do math, we'll just go to the next topic. So up to you, whichever you want to do. Right. So I'm following your working, Ainesh. Oh, today your video is very nice. I like your video too.
I don't know what I'm doing actually.
Show me the. Oh no, I can see the question. Okay. So again, I'm asking you, right? So what type of question is this?
Reversal.
I agree with you. Good. So I cannot see this. I cannot see this clearly. Tell me what this is again.
What is this?
What is that? So I cannot see your working also clearly. So
can you see the question?
I cannot. Just tell me what this is.
Okay,
just tell me what this guy is.
It's ln. Then 1 by ex.
Ex. Okay, ex. Okay. So is this e lah? Right? So again, please notice that ln is not AMMA lah, right?
Yeah.
It's not right. I would jump forward and do magic like question 1, and I would say, oh, the basic graph should have some ln.
Yeah. E
okay,
also.
So,
actually, I don't know about E.
No. So the thing is you're just not used with E. Remember, E is like pi. What is pi?
Oh, I thought E also was a random variable.
No. So it's not a variable. That's the important thing. It's just a number.
Okay.
It's just like 2, you get what I mean? It's just like 2.
Yeah.
Right? However, just a little bit, something that bothers me is that, okay, the translation and the reflection doesn't have E. So I'm not sure. Maybe E will also be part of the original, but it's because I noticed there is no translation and reflection in terms of E. I just noticed that because I can actually translate by E. I can. Understand it? Understand it? Right. So now, your A and B, you did not do what you do in example 5. In example 5, you spell out everything in reverse first.
Oh yeah, I didn't do that. I just
Now,
went
do
straight
you
into
want to do that first, or you purposely skip that?
I purposely skipped it for the sake of time and stuff.
Yeah, but then you say you don't know what you're doing. You nonsense, right? Okay. So do you regret not spelling it out?
Yeah.
Okay, okay. So just tell me the reflection in the x-axis, right? Reflection in the x-axis is reflection times the fx or times the x. At least tell me that lah.
X.
Uh,
Is it not? Reflection of the X is the x-axis.
yeah, I'm gonna draw it visually. Yeah. Everything is solved by visual in this topic, and you have more than enough visual capability. So here's a point, right? Don't care what's the graph. Now I will reflect this point in the x-axis. It's a weird phrasing. So which one? This one is the new guy, or this one is the new guy. Which one is it?
The first one.
First one. So this one's wrong. So this is, I will call this reflection by the x-axis, not in the x-axis. So if I want to go back, I'll also reflect it by the x-axis, just say. Now, give me a reasonable coordinate for this guy.
1, 3.
No, it should be -1, 3. Okay,
Oh, sorry.
because right. So now if I reflect it to this guy, then it will become what? -1, comma.
-1, -3.
Yeah, so see, y-axis. Not y-axis, sorry. The y, not the x. You made a mistake there lah. It's the y, not the x. So it's the fx, not the x. Now look at your example 5. This is covered in example 5. So you draw whatever you want, look at example 5, and understand that you're supposed to know this in the sense lah. So you work on it lah. Aryan, can you find the summary, or is it lost?
Yeah, I found it.
Show me.
It's the Ochem holiday tuition.
I thought there's supposed to be a hard copy.
Hard copy?
It's only soft copy, really.
No, I mean I have a hard copy, but I'm having trouble finding it.
No, never mind. You found the soft copy in the Jamboard, right?
Yeah.
Now, very quickly, just redraw that. You can look at the Jamboard, redraw that, but ask questions, not like, oh, wait, I don't understand what this means. Wait, I don't understand what that means, right? So just retracing and putting question mark. I'll answer you one by one, and then should be okay for now. Okay, so we have a good start, Ainesh. Now, you okay? Have you seen the example 5? Please look at example 5 and realize that they actually taught you this. The C.
Yeah, they did.
So reflection in x-axis is y, not x.
Yeah.
Would you find the English weird again?
The English is very weird for everything.
Fair. What you say is fair. I won't object. So if it is weird, it should grab your attention more. That's the most comforting I can say for now. Okay. I offer no explanation except the visual side of things. Now, so that's B. That's B. Now, for the 1-1 translation, so tell me, 1-1 means move to the left by 1 originally, and move up by 1 originally, correct?
Down and move to the right.
Correct. So your minus, I don't think is a big problem. So kindly do your minus properly, because something is wrong at the start, right? So just correct that.
See? No, we got no question. Very messy. I'm sorry.
Yeah. Oh, I know why it's messy. Oh yeah. It's okay. Give it a try. Right. So Aryan, as you copy things, I don't mind, but remember to put question marks at tops. Okay, wait, I don't know what this is. I don't know what that is. Why is this like that? Why is that like that? Yeah. So you put the question mark accordingly when you write, not afterwards. Yeah, not afterwards. Right. Even the arrow direction can be a question mark. Just saying.
Yeah.
Okay, now Ainesh, surprisingly, I give you a good surprise. Surprisingly, this question is very easy to confirm. We haven't been talking about confirmation for the longest time. In this, like, it's a big thing. Now, this particular question is totally easy to confirm. Let me tell you. You have arrived at the original equation. That's your proposal. Okay, my proposal is this is the original equation. You only have to go through A and B. And if it arrives at the supposed result, then you must be correct. So just run through A and run through B. I hope you're correct. Look, very easy to confirm. Please do that. Remember the AMMA, you still have to follow the AMMA order lah. Right? Just saying. That's it.
Can you see my working?
Yes, I can.
So yeah.
Okay, so you're getting already, okay, you're the -1 + 1. Okay, good, it's gone, good. Then I would argue that you want to do the x first, but okay, never mind, you're just jumping, no problem. So done, then, okay. Now, is this the final, is this the supposed final result?
Yes.
Then you are correct, unless you make total mistake everywhere, but it seems to me that you're correct.
Yeah.
I would argue that this question 3 is not that scary for this fact.
Yeah.
Okay. Now, I really hope that your teacher will discuss this and make you happy if you're correct. If you are wrong, then still make you happy by knowing what is wrong.
Yeah.
Okay. I'm happy with the way you think so far. I'm happy.
Yeah. Thanks.
Yeah. That means I'm not telling you whether you're correct or not. I'm not, who cares, let's torture Ainesh for a while. Okay, anything else that we can or should do? We still have 10 minutes left.
Not really, because even one of these will take me a long time, and there's no more questions, so I guess.
Right. Can I confirm that the future topic will still be Trigo if that's clear now? Is it?
No, it's not. Nothing is clear.
Right. Okay.
After June.
Okay. I will see you tomorrow at night then.
Okay, sure. Also, right. I have holiday on Wednesday.
You have holiday? Yeah. Wednesday, again, the same thing. If you're asking for Monday and Wednesday, my answer will be the same one, okay? If you want certainty, it's night, but if you think you can afford the, uncertainty, then I will tell you like on the afternoon. But, it's uncertain.
Sure.
Same thing. Okay, you sure you won't die of math, overdose, Sunday, Monday, Tuesday, Wednesday?
That's true. I'll see after Tuesday, but I mean, I have a whole 2 weeks to blow off steam, so
yeah. And today you're fine also.
Yeah.
Okay, let's do that.
Okay.
See you tomorrow with the homework. Bye.
Bye. Good night.
That's not how you write substitution, Arya. A bit of a spelling error. It's not substitution, right?
No.
Substitution. No I. Yeah, there's no I there. Yeah. Okay, good. Yeah. So that's it. Right. Can you move to the right first so I can see whether you have a question mark on the left hand side? Could you please move to the right? Move to the right a bit. Okay, thank you. Okay. Okay, sure. Can you look at the bottom part? I see. Okay. Now, here's the good news for you, Aryan. You have a lot of question marks, yes?
Yeah.
For a topic that formally you have not started. Okay, you have not started this topic at all, right? So I think it's a very good news. It's a very good thing that you have all these question marks. What do you think about these question marks? Is that a bad thing? Is that a good thing? Is that a negative thing? Is that, I don't care? What is it?
Since I haven't like learned the topic, I guess it's a good thing because like it lets me get to know the topic better.
Okay, I'm trying to shake you a bit, but question mark means you do not know about the topic, not that you know about the topic. So why are you happy about that?
No, I mean, it lets me know about the topic better.
It is true that you know the topic better than your class right now, true lah. But how does the question mark help you with that? Or the question mark is the gap, right? What is it?
Yeah. It's like when I like clear the question marks, it'll help me like be better at the topic. If that makes sense.
Right. I think I like it, right? I will argue that you knowing the question before the class is very good because then you will pay attention to the answer of the question mark.
Yeah.
Right. So this is formally the first time you have expectation of the class. Let me just I'm assuming that previously if you attend a chemistry class, you have no expectation, as in whatever is there lah. That's my assumption. If I'm wrong, please tell me.
Yeah.
But now you are different. Now you're a good student. Now you have expectation. You have a demand on the class. What is your demand of the class?
To get to know the question marks.
Yes, to know the answer. I don't mean demand means you raise up your voice. I don't mean that. I mean, you expect the class to answer these questions and maybe more, but at least these questions, right?
Yeah.
Now, I'm not sure whether it's a good news or bad news, but the class will start answering this question in 1.5 weeks time or 2 weeks time. So not that fast, not that fast, right? So yeah, something like that. Now, should I answer some of the question mark or should you let the class do that for you?
I think you should answer some of the question marks.
To honor your question mark and your effort, is 10 minutes. I will answer one only and let the class, because if the class doesn't answer you, I am worried. You should tell me that. Man, the class is not addressing that at all. Wait a minute, like maybe I missed the syllabus. Maybe that's one option. Or maybe the class something wrong, or maybe you sleep in the class. Don't know lah. But you tell me lah. But you must tell me. Understand?
Yeah.
Now, you feel free to choose whatever question mark you want. I'll explain for you.
Probably this bonding.
Okay, again, tell me what the question mark is. Which one is your question mark? Like what's going on there for you?
Like why is the bonding so weird there?
Okay. Let me try to answer that if I can, right? Okay. I'm going to show you something. You can see my video, yeah? Yeah, feel free to look at my video for now. So you don't have to show me your video. Just flip your phone and then see me lah. That works, right? Just flip your phone to your face and then you can see my video. Then I cannot see your page. Doesn't matter. Have you done that? You haven't flipped your phone to you. Just flip your phone screen to you so that you can see me. Okay, can you see me now?
Yeah.
Okay. The carboxylic site. Now, the weird thing that you mentioned, why the bond is so weird, is the most important, bond in carboxylic acid, whatever that carboxylic acid is. That means you have to understand it. So it's a good question. Okay, I'll try to answer that. get some coloring first. So this is a CO2. Can you see my video? CO2.
Yeah.
So black is C, and O is blue, light blue, as in the color. I hope makes some sense. Okay.
Yeah.
Also notice that C has how many hands? Did you notice that? How many hands does C have?
It has 2.
No, nonsense. 1, 2, 3, 4.
Oh, yeah.
Right? Does that make sense? C has 4 hands.
Yeah.
Okay. O has how many hands?
2.
Good. Make sense?
Yeah.
Good. Now, you're not doing CO2. You're doing something else. So, okay. Look at that. Okay. Who is this black guy?
That's OH.
No, the black guy only. Just the black. Just black.
Oh, CO.
No. Black is only C, not CO.
Yeah.
You notice that this black C has how many hands? You look. How many hands? So 1, 2, 3, and then 4. No surprise, right? 4, ma? C always hands. Now, the other C, how many hands?
4.
4. So again, no surprise, ma? No surprise. This C is not complete in the sense that we are ignoring what's happening here. It's not that he doesn't have anybody, but we're just ignoring it. Do you notice that this C and this C is exactly what you draw? I'm going to flip it so it's easy, isn't it? That's what you draw. This is the first C hanging around, and then this is C, which is going to be complete. Understand?
Yeah.
Okay, now the C have 4 hands. 2 connects to the connects to who? Oxygen. So oxygen 2, C dedicates 2 for him. Make sense so far?
Yeah.
Right. This C has 4, so he dedicates 1 to the neighboring C. Again, makes sense, ma? Always must be like that, ma? Then the last one he dedicates to who?
The O.
Which will have 1 more hand, and this orange. So this orange is a new guy. So this orange is the H, no?
Oh, H.
Right. So I'm not explaining anything right now. I'm just telling you that, oh, the COOH, COOH, kind of looks like this. Kind of. I'll say kind. Does this explain your question, or there's still more question?
Yeah, it explains my question.
Right. So I'm going to finalize it by taking off everything. Who are these two?
C.
Which is one C connected by another C. Done, right?
Yeah.
So what do I do with this C? So this C is the one we left hanging around, right? Just leave this C over. Just leave this C as it is. But this C we have to fill. So how do we fill this C?
You connect the O.
Okay. Here is an O, right? O has 2 hands. I connect it with the 2 C, right? I'm going to do that. There you go, right? See, my CO. Make sense? Then what else do I do?
You connect another O with 1 hand.
Okay, another O with 1 hand. So I take my O. Here's my O. 2 hands. Sorry. Here's my O. 2 hands. See, I'm holding 1, right? So I just connect this. And then this I'm going to connect with that guy. Would that be okay so far?
Yeah.
Okay, then what else do I do?
Then connect the H to the O.
Because he needs it, right? You cannot just leave it like that. So here's my H, right, with the connector. And voila. Okay.
Yeah.
Now, if you want to write some answers to the question mark, go ahead. You can do it right
now. No, but then it's like you can leave the C hanging, but then why can't you leave the O hanging?
Okay. So this is a summary, right? No, the C is not hanging. The C is connected to many other things. Nothing can be hanging. But in our summary, we focus on this just to say that this is the most important feature of a carboxylic acid. I'm not saying that this C is hanging. I'm just saying that this is hanging for our convenience. There are things here.
Oh.
Definitely things here. Definitely. If let's say there are no more C here, what must this have? It must have something. What must it have?
H.
Yes, that's what you do all the time when I teach you, right? So, oh, nothing else, H. So CH3, correct? CH3, just not here. COH, well, that's very familiar, isn't it? CH3, COH, what's that?
Oh, I said ethanol.
No, ethanol is alcohol, the other guy. Like this is group 4.
Ethanoic acid.
Yes. So you already know who this guy is. Now we are learning it in more detail. Are you happy?
Yeah.
Right. You want to write something first?
Yeah.
Right. So now we will flip back, so I can follow you again. Okay. Write whatever you wish. Are you okay? Are you happy with this so far?
Yeah.
Sorry, because I cannot follow. Are you done? Sorry, I thought you were done. Sorry.
Yeah, I'm done.
Right. So having expectation in your lecture or your class, I hope it gives your class additional meaning, right? Additional sharpness. Basically, just make your class better, right? Hopefully, you as a chemistry student will end up enjoying it, right? Now, at this point, you have two options. I'll tell you the two options. I didn't cover everything about Ochem. I cover around 60 to 70. The most important summary I covered, so it gives you a good expectations. We can cover what you call the formal naming of Ochem. Never teach you this. The reason why I never teach, because I notice most students, even my students, not just the whole Singapore, just my student almost never ask question on the naming. That means in class, they have enough practice. The naming they can handle. They just ask question in exam 1, right? So, however, I can cover with you a little bit first about the naming so that you have some expectation, right? That's one option. Okay.
Yeah.
Right. So the second option is we just go to A method. The next integration topic, same thing, just discuss it, create expectation, makes your class better. Okay, so you choose what you want to do.
Since we are like on Ochem right now, why don't we just continue for a while?
Right. Okay. So the naming thing, something new. Let me show you in Jamboard.
With Jamboard?
Yes. Let me see your Jamboard. I think your Jamboard is still very empty. So let's use the previous Jamboard. Right. And let me keep my stuff first. Okay. Draw for me an alcohol, please. Any alcohol that you can, as long as you draw an alcohol. Don't make it too simple, please. Can you do that? hit the Jamboard. Sorry. On the paper is fine. On paper is fine. But draw an alcohol for me. Nothing too simple. I cannot see your drawing though. Yeah? I cannot see your drawing. Maybe you zoom out a bit. Maybe that's better. Yeah, I think you definitely have to zoom out a bit. It's a bit too big already. Zoom out a bit. Yeah, around there. Yeah, sure. Okay, show me the drawing of your alcohol. The spelling of, I'm sorry, the spelling of alcohol is not the H in the middle doesn't have, right? So ALCO, so the H, the alcohol spelling is correct. Yeah, nice. Okay, now show me the drawing of your alcohol.
Here.
No. Draw for me a complete one and not this symbol, please. Something, maybe it's longer or something like that. Right? I want you to create an alcohol like this. That's a carboxylic acid. So I'm not saying that you cannot have a carboxylic acid in an alcohol. This is not an alcohol. The OH here is not alcohol. The OH here is COOH. It's a carboxylic acid. However, since you already drawn this, it doesn't mean that you cannot add another OH. Try adding another OH in the first C. In the first C, not in the second C. The second C, you cannot do anything. The first C, if you put OH, that will work. Do you understand why it works? Because the C is connected to the O, not the H.
Oh, yeah.
Right? Okay. The drawing doesn't make it clear, but so this is both an alcohol and a carboxylic acid. Does that make sense to you?
Yeah.
Right. And this is what is going to happen in exam. In exam, they don't give you one type. They give you 2 types, 3 types, double 2 type, whatever. So this is normal for exam. No surprises. All right. Ken?
Yeah.
But for naming purposes, let's not do this. For naming purposes, just go with something that doesn't mix the group. So make an alcohol. Don't mix with carboxylic acid, but make it slightly more complicated, please. Like longer or something like that. Right? Longer means you may have to have longer C, something like that. Oh, wait. How is this different from your alcohol that you draw? This is still 2C. Like what you draw in the summary is 2C because, for simplicity, this is also 2C.
Oh.
This is, wait. To be fair, do you think that this is different from your summary? If you think that it's different, please tell me.
No, it's not different from the summary.
Okay, so make it different from the summary, and the way to do that is to make it longer. So add more C, basically.
Oh, okay. Yeah.
Right. Okay. Okay. So I just have 3C. Okay, sure. Yeah. Okay, good. Okay, nice, good. Now, before I give you the naming, I'm going to ask you to draw another alcohol with 3C, but make it different from this one, if you can. Okay, also 3C, also alcohol, but different. Interesting what you're doing. Okay, interesting what you're doing. One more, please. One more alcohol, 3C. Also alcohol, but different. Okay, all right, okay. So you think that the first guy, second guy, and third guy are different now. Am I correct?
Yeah.
Now I'm going to show you the naming. So before I show you the naming, I'll tell you this. If they are truly different, their name will also be different. If they are not actually different, their naming will be the same. Right? So the naming and the fact whether they're different or not is like super consistent with each other. That is the beauty of the naming. Okay?
Yeah.
Right? I'll tell you that first. Now, show me, because move up a bit, I'll copy everything. Now, your teacher, when teaching you naming, will probably give you the rule first. Go up, go up, go up, 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 up. Okay, nice, nice. Okay. Me, I'm not going to do that. I'm going to name it, and you're going to figure out what the rules are by yourself, by looking at me. Understand? You look at me how to name them, and then you're going to figure out the rule of the naming, and you're going to confirm with the last question. Is it how you do it? Is that how you do it? Understand?
Yeah.
Okay. I'm copying them to the Jamboard first. Now, I'm going to use some numbering. The numbering is not formal. The numbering is for my sake. It's my working, right? So, for example, I number it this way. 1, 2, 3. I'm not saying that there is like 1C here and 2C here and 3C here. That's not what I'm saying. Okay, I'm saying that this is C number 1, C number 2, C number 3, but this is not formal. This is how I would do it, right? So it's just a working. Understand that?
Yeah.
So watch for the first guy. Before I name, I say, oh, okay. Then I'm ready to name. The name of this guy is, if it is a tree, it's gonna be a weird name. The name will be, wait, I forget. Oh. Let me just clarify this. The name of this guy is not propanol. Is propan 1 all. The meaning of this one is very simple. It's all refers to the alcohol, yes? All at address 1. Propan address 1 alcohol. Propanol. Propan 1 all. Understand?
Not really.
Okay. If you don't understand, look at me naming the second guy and third guy, that you may see some pattern. Are you ready?
Yeah.
What am I doing? I am giving address. This is address. Address number 1, address number 2, address number 3. Understand? Okay, that much I can tell you.
The number of OH ions.
OH, don't call it ions. They are side change. So you're saying, right?
Is the number based on the OH bond?
No. There is a reason why I named this 1 here, not 1 here. There is a reason. Right? There is a reason. Now, you guess why. What's the reason? Now, second guy first. Second guy, I have finished naming the addresses of the C. Then I will still go propan. No surprises, right? The propan, no surprises, right? Watch me. 1, 3. What does 1, 3 means? Address 1 and address 3 lah. Okay. Then diol. Okay. Di is a common prefix. You understand what di means, right?
Yeah.
To all. Propan, address 1 and 3, to all. Propan 1, 3 diol. Understand?
Yeah.
I'll give you an alternate naming. 1, 2, 3. That's how I will address it. Okay. The name is, do you notice what's the name if I use the alternate address? Still the same thing.
Oh.
Right. For the red address is address 1 and address 3. For green, address 1, address 3. Where the same thing was. So the address will work whether in red or in green. Okay, the address will work either in red or in green. Now I'm going to do the green for the first guy. 1, 2, 3. That's the alternate address, correct? In the green side of things, I will say this is propan, address 3 all. Yeah. Not acceptable because there is a smaller alternative. That's the only reason why.
Yeah.
Okay. You're sensing the rule. I'm not saying that I'm not telling you the rule. I'm just implying the rule. Now, number 3. Number 3, first address. I will do that. Okay. I finish my address. Maybe you can already guess what's the name here.
Is it propan dash
Right.
1?
Yeah.
1,2 dash diol.
Can you imagine the green alternative and whether that is acceptable or not?
Propan like 1,3 diol.
No.
2,3 diol.
2 more. And not acceptable because I have 1,2.
It's bigger. Yeah.
Yeah. So just choose the small. You're already getting 80% of the naming rule. By the way. This works across the board, not just for alcohol. Now, any questions so far?
No.
I'm not saying that you can even say out the rule, but I'm saying that you seem to be accepting some part of the rule. Okay.
Yeah.
Okay. Now, I challenge you. I'm going to do it in page 6, but you're going to create the things first. So now create at least 4 C, meaning to say, I want you to now branch the C. Do you understand what branching the C means?
Yeah.
So branch the C, and then you can decide whether it's going to be alkene, alcohol, or carboxylic acid. Meaning, don't touch the simple guy. The simple guy is alkene. No? Just do either alkene, carboxylic acid, or alcohol. But make sure that the C is longer than 3, and if possible, later do some branching. So at least create 2 or 3 of the the similar guy. Yes.
Yeah.
Okay. Wait. Move up a bit. Okay, I like all are 4C. The second guy I don't like, that's alkane, so make it more complicated. Don't choose alkane group. Yeah, either alkene or alcohol or carboxylic acid, right?
Like this?
No, you cannot double bond a H. Hello.
Oh yeah.
Right, that the double bond exists between C because H only have 1 bond, right? I mean, I appreciate that number. I'll call that number 4. Yeah, is similar to number 3. You cancel number 2, right? But try recreating number 2 with an alkene. At least do some alkene here, right? So number 2 with alkene with double bonds. So observe your summary one more time. The double bond is between C, not between C and H, right?
Oh.
Right. I cannot see that guy. Could you please move up, please? Okay. Very interesting. Oh, you got it all correct. Oh, I like it. I like it. The hands are all correct. Oh, I like it very much. All right. So one last challenge before I name it. Please branch the C. Do you understand what I mean when I say branch the C?
Add more C's?
No. Stick with 4C, at least for a comparison, right? So no. I'll show you. So I'm sticking with 4C, but I'm branching the look in Jamboard. You see what I mean? I'm branching the C.
Oh.
Okay, do this and make it complete, do whatever you want, but branch it. So do one, please. Do one like this.
But all already have 4 hands.
No, nonsense. This guy has 1 hand. This guy has 3 hands. This guy has 1 hand. This guy has 1 hand. What are you talking about?
No, I thought you wanted me to branch in this.
No. The one you have drawn is fine. Create a new one with a branch, like what I told you. So one more. Okay, I'm gonna copy this first. Wait, the hand looks okay, right? Okay, now the previous page, please. I'm gonna copy what you've done. Okay, move up first. Okay, I'm gonna copy these 2. And then okay, then move down, please, so I can copy the first one. Okay, nice. Okay, I think I have finished copying. Excellent. Now, please refer to the Jamboard, and I just lost your video for some reason.
Oh.
1, 2, 3, 4. Okay, good. Okay, so we have 1, 2, 3, 4. Okay, good. So make it landscape, please. Okay, nice. Now you can keep it like that. Sure. Now, observe me. I always start with the address, right? The address numbering, right? So, just to make it clear, I can address it the other way, lah. Okay?
Yeah.
Which one do you think is appropriate? The red address, the green address, or both is fine?
I think the red.
I'm going to do red first. So for 4, the name is Bhutan, right? Weird stuff, right? But you just have to memorize. Okay.
Yeah.
This shouldn't come as a surprise. The green one is problematic because why?
Because the numbers are bigger.
1, 3, 4. There lies your problem.
Yeah.
Okay, good. So first one, clear, right? Now second one. Second one, I have a choice between the red guy or the green guy. Now, This one I have to tell you, they have given priorities if they cross group. So this because you cross group for me, so I have to address that. So you cross group, you have alcohol and you have carboxylic acid group. You have two groups, they have a list of priority. So I'll just make the priority very clear to you. The priority is reverse of your summary. Your summary goes from alkane, alkene, alcohol, carboxylic acid, correct?
Yeah.
The priority goes from carboxylic acid to alcohol to alkene to alkane. So the priority goes backward. Okay.
Oh.
Who decide all this? They decide all this. Whatever, I just follow. Right? But it's okay. It's okay to follow. So that's the sole reason why I choose red over green, because the red gives priority to the carboxylic acid. The green does not. Understand?
Yeah.
Okay, so I will have still Bhutan, right? Bhutan, and then I will have one, right? One, oic acid. We'll start, right? Bhutan 1 oic acid, then dash 3,4 diol. There. Are you okay? Yes.
I don't think this is. Wait, no.
Tell me your question. Tell me your question.
No, I was gonna say I don't think this is correct, but then I just realized that you need to give the carboxylic acid
Priority.
priority. Yeah.
Correct. Correct. So that's the only reason why I'm doing red, because priority between groups. Okay.
Yeah.
Now, notice that this guy also have priority, man. And has the priority because you have alcohol and alkene at the same time. So who are the priority? Who is the first guy to go?
Alcohol.
Correct. Because that's just how it is.
Yeah.
So I will be naming it by red. Though by now you should know why I go with this lah. I don't go with green lah. Right? Should know. Now, so how do I name it? Still Bhutan, huh? Still Bhutan. Bhutan. So I think I need to go 1,2 diol. Yeah. And then 2,3 diene. Right. Any questions over?
No.
Right. This guy, the address is what? The address of this guy is who?
Sorry?
The address of this guy is?
Diene.
No, the address. Address number. Address number.
Oh, 3?
No, 2. The address of this guy is?
3.
3, not 4.
Oh, okay.
Right?
So it's like the left side of the C.
Not the left side, the smaller number. This guy can be addressed 2 or 3, small number low. This guy can be addressed 3 or 4, a smaller number low.
Oh, okay, yeah.
Always smaller number. Now you see some trend over here. Okay.
Yeah.
Now there's nothing wrong with what you draw here, except that this is not branching. I will show you why. This is not what I asked you to do. Isn't branch it now? So let me show you. So I will do this one. 1, 2, 3, 4. So the green option is not my option because 1 is better, right? So yeah. Observe. So Bhutan. So observe 1, 1, 3 trial. Observe carefully. Do you understand what I'm doing?
Oh yeah, because it's 2 OH.
2 OH in address 1. So I actually repeat the address. No?
Yeah.
So it's not once, no, it's twice. Just 1, 1, then 3. Right? Clear, yeah? Now, yeah. I'm happy with this, no problem, but this is not branching. So observe this one. Now, I want you to draw this exactly and then, make it complete, and then I'll name this for you. This is, I think we can stop the naming lesson at this point. Should be more than enough for you to understand it. Right, so complete everything first. Okay, I'm gonna copy that. Now observe what happened when I name this. This is important. Right, so I will go, my priority will go like this. So 1, 2, 3. 1, 2, 3. Just to be clear, this is not 4. I cannot do that. Just to be very clear.
Oh, yeah.
Yeah. I have other ways of addressing though. So I can also go, for example, 1, 2, 3. I can do that. All right. I can also do blue, for example, 1, 2, 3. I can also do that. Right. Actually, therefore, there are variations in this addressing precisely because of the branching. The branching does make things slightly more complicated. If there is no branch, then it's just back and forth. Okay.
Yeah.
Now, understand that there's only one proper one. So again, I'm just choosing the red one. So
Yeah.
it's gonna be very weird, yeah. So because I choose the red one, notice that this C, which is not part of the address, will now be considered a side chain. So he becomes a side chain, right? He becomes a side chain. So observe what I'm doing. Yeah? So first, I noticed that the red only covers 3 propan. So I do that first, and then propan, I'm going to make the address. So 1,1, and then comma 2, 3. Yeah. So 1,1, 2, 3.
Yeah.
Wait, oh, tetraol. Yeah, tetraol. Don't see this often, but tetraol. Okay. Now I finished the 1, 2, 3. So 1, 1, 2, 3 tetraol, and then I have to now contend with the side chain. Now observe where I put the side chain. This is a weird, but that's how it works. I put the side chain in front. Why? Yeah, that's the rule. I'm so sorry. Yeah, that's the rule, right? It's a rule, right? So it's a rule of address. Okay. So I put it here, and I'll put this as methyl, and I'm done. Obviously, the one with branch is much more complicated. Now, any questions?
What if like the side chain also has OH?
You have to write methyl alcohol. Yeah, you have to write methyl alcohol.
Oh, so what would then like the numbering be?
Well, we have to create something new. Right? Now, obviously, you notice what I'm doing. The rule states that you have to cover the weird guys, the identities, the alcohol, the as much as possible in what you call the main chain, as much as possible, right? But if let's say this guy have alcohol also, then you say methyl alcohol, propan, blah 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 tetraol. Okay.
Yeah.
Right. Thankfully, they don't test too much on that, but they do test a lot on the side chains. They do. Right. So they don't go all their way to make it too complicated. They actually take real life stuff. Real life stuff is how do I say this? You'll see soon enough in the exam question. What are considered real life stuff, right? Okay. Now, any other question? If you have a question mark on the side chain, excellent expectation on your class. Excellent. I want you to pay attention on it. Right? Okay. Now, there is no practical need to explain more than this because usually people do understand in class. I would expect that your class will be able to, explain to you and give you enough practice also. People's problem are usually not the naming per se, usually. Okay. Right. Now, do you have a question?
No.
If you have, put the question mark. Right. If you have, put the question. Okay. Yeah. Clear. Yeah.
Yeah.
Right. So I have created with you the expectations for your class. This is 90% of Ochem. The rest are just getting used to it and doing the exam questions. Very prepared for your class, I would say. Very prepared. What shall we do in the remaining 20 minutes?
A-math.
Right. And what would you do for A-math?
The integration.
Right. So the new integration. So let me confirm that you are still doing the area under the graph, or you have not done that.
I think most probably done by now.
Do you have homeworks? Have you practiced some homework on it?
Yeah.
It's important. Okay. Then let me confirm this. For your integration, you have covered the area under the graph. You have covered the trigonometry and the logarithm integration, right?
Exponential as well.
Exponent. So that's all the basics done. You have not covered kinematics.
No, not yet.
And you have not covered the differentiate then integrate, or have you?
The hands question.
The hands question. Yeah.
Yeah.
Oh, that was in the exam, isn't it?
Yeah.
Okay. Then that means all you have to cover right now is the kinematic one.
Yeah.
So we are going to kinematic, right? So surprise, I'm just gonna immediately give you an exam question because it's not that difficult. Let me show you what I mean. The difficulty is the reading of the question, not the integration itself. The integration is not as... The hardest thing is the hands. The hands integration is probably the hardest one. Other integration question, the hard thing is not. It's not that. Okay, so let me go and take a kinematic question. Kinetic question always exists. Just a minute. That's weird. Sorry, weird because you should have. Oh, there you go. Now, kinematic question will feel like physics or E-math, either way. So please check out Jamboard page 7. You're reading it, and there you go. So does this question feel like physics or E-math or both, or actually none? It feels new.
It feels like kind of new.
Right. So let me give you why I think it is similar to E-math first. Look, average speed. Let me think for a while. Yeah, E-math likes to ask that one. No, wait. Does E-math ask that? Wait, maybe not. Actually, maybe not. Maybe not. Sorry. Never mind. The E-math question usually have a picture, a graph. The A-math does not. This is your E-math problem. Right. So you're saying that this is not similar to your physics and it's not similar to your E-math. Okay, I won't force the issue. So I just treat it this way. Now, I will, however, jump to physics. This is the only way to explain. So I have acceleration, I have velocity, and I have displacement. Now in math, displacement is given as S. Is super weird, but it is S. Okay.
Yeah.
So notice that I write A at the bottom of V. I write V at the bottom of S. Why is that so?
Sorry, I didn't hear that.
I write V bottom of S. I write A below V. Why?
Oh, because the gradient of the S, the distance from time graph is V.
Sure,
and the gradient
sure.
of the
Yeah.
time graph is V.
Now, isn't that physics, right? Oh wait, that's physics or E-math? Sorry for you. Is that physics or E-math?
That's physics.
Physics, right? But E-math also, right? So both. Now, this is our informal agreement, right? If we write below, it's differentiation, correct or not? Formal agreement. But wait a minute, we're discussing integration. Well, if this is differentiation, then this is integration, no? Same thing, correct? I hope it makes sense, huh?
Yeah.
Right? Now, look at how the question is positioning itself. Look at what he gives you. Does he give you all three or he gives you one?
Gives me one.
And very frequently, 80% of the time, he gives you V. Do you know why?
Because you can like integrate to find out the distance, the displacement, and you can
differentiate
to find out the acceleration.
Right. So what kind of question is this? It's both, no? Simple,
Yeah.
Right. So this is what you would expect. They give you V. In E-math also, you know, in E-math, you expect to give them to give you V because then they can ask you both direction. Okay, if that makes sense, huh? Right? 80% of the time, right? So I'm going to write down very carefully. So the dv dt is not dx. Can you accept that? It's dv dt.
Yeah.
Is A, and then this is the ds dt is below, and then the reverse is just integration. At this point, not much complication. This is what is going to happen in kinematics. Okay, so far so good.
Yeah.
Now, let me ask you a few questions from the question maker perspective. So one more time, the question maker gives you blah, 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 all important stuff. He also gives you the V. So happens he set a K here, right? So maybe to, you know, make things slightly harder. Now, why does he give you additional information here? Why? Please tell me why he gives you additional information.
To find K.
Seems legit. Can you now try it, please? Okay, zoom in a bit, please. A bit difficult. Oh, you have completed it. Okay, sure. Right, so case 20. Let me just see. Everything looks fine here. Yeah, okay. Right, so I'm telling you something important, important later. So when they give you the information, do you notice that they give you acceleration and time together? You notice that, yeah? Okay, together. You will see this repeat later on. So I just want to take note. Okay, your 2 marks clear? That easy, yeah?
Yeah.
Okay, now look at B now. Now think carefully. What is this B asking? What's that? Right? What is that?
It means that V is equal to 0.
And he asks you for the T, right?
Yeah.
Can you do that?
Yeah.
Okay, you good. Good. If you're reaching for a calculator, I like it. Good.
Since V is equal to 0, does it also mean that A is also equal to 0?
Back to physics, please. Very important. Huh? There's no answer in math. It's answer in physics. If V is 0, is A 0? Physics, eh?
Yeah, I think.
Nonsense. No, wrong. Let me explain later. Could you do this? Do you need that for this? Do you need that for this? It's a good question, but it's wrong.
I thought we needed that for this.
Oh, no. First thing first. Now, why don't we need that for this? First thing first, you're dealing this in the V level, not in the A level. Do you need to go to the A level?
No.
Okay, you're dealing this in the V. If you don't need to go to the A level, then you don't need what you just said. Okay, fair enough?
Yeah.
Okay, so do this first, and then I'll explain the physics of why it is wrong.
I'm getting like very weird numbers.
Tell me. I don't think it has to be pretty. So this is 7 comma, right? Let me see. 7 comma. Go move down a bit. Move calculator down a bit. Okay. Then one more. Oh, and minus, right? So do we take both?
No, we reject the minus.
Right, but why? Why?
Because time cannot be negative.
For now, we'll accept that answer. But okay, your answer t equals to that and your final. Now, how should your presentation be? Let's talk about how should your presentation be? You cannot just say press calculator, right? So your presentation should be like what?
Should we do the quadratic
Formula.
Yeah,
you should do the formula for presentation. You don't have to do that now. Understand that you have to do it now. Okay?
Yeah.
This is basically a quadratic question, no? As in, that's why it is easy to do, right? Okay. So done. For 4 marks, that's not so bad, right? For a topic that you haven't done before. Right? Now, before we go to C, let me explain why or that, and then reject it. Then reject. You have to reject to get the 2 marks. Again, you have to reject with a reason internally, but you don't have to explain the reason to the examiner. Okay, so now let me explain why when v is equal to 0, a not always 0. In fact, it's not common that when v is equal to 0, a is equal to 0. So what you're thinking is this. What you're thinking is something different. What you're thinking is this: when versus when the block is not moving, obviously the acceleration also 0 lah. Obviously, no?
Yeah.
Okay. When something is not moving, obviously its acceleration is 0. Totally agree. And also you will argue, wait, not moving means v equal to 0. So wait, you're correct what? V equals to 0, a equals to 0 lah. This is not that. Let's be very clear. Let me show you a few ways. Look at my video. Now I am throwing something, right? I'm throwing something there. Okay, Ken? I'm throwing something there. Now there's no surprise here, right? I throw up, it goes down, right? Okay, now I'm going to do a slow motion. I throw up. Sorry. I throw up. Now this is the peak. What's the velocity in the peak?
0.
What's the acceleration in the peak?
0.
Nonsense. Okay, so let me explain that. Right? No. Your physics is bad, right? Not your math. Yeah? This is your physics being bad. So you do learn physics. So let's look at it from that perspective. Let me draw you something else. Okay. This is a V and T diagram. Okay. So this is a simple line, right? This is a line in the Jamboard. Yeah. Now, where is there is a point where V is equal to 0? Where is that in Jamboard? Please tell me. Use the laser point, right? Where is it? Are you okay with the Jamboard? Page 7. Okay, there you go. Yeah. Okay, so this is where V is equal to 0. And let's say this T is, I don't know, equals to 3. Let's just say, okay?
Yeah.
Okay. Right. Now look at this graph carefully. This is V equals to 0. Is the gradient 0, not 0, or don't know?
The gradient is less than 0.
Yes. So the acceleration is not 0.
Oh, okay.
So let's understand that further. So obviously it can happen the other way, right? Obviously it can happen the other way. Then, right? V, T, let's say this T equals to 2, V equals to 0. Acceleration also not 0. Now, let me show you the graph where the V is 0 and the acceleration is also 0. Let me show you that. Do you see that? This is V equals to 0 and acceleration also 0.
Yeah.
Let me show you another graph. Again, physics. This is not math. This is not math. This is physics. Look at this. V is not zero, as in V is negative, correct?
Yeah.
But what is acceleration?
0.
Yeah. Now get this clear, Aryan, from a physics perspective. V equals to 0 does not always mean A equals to 0. Does not always mean that.
Yeah.
It can be an instantaneous rest. What do you mean by instantaneous rest? It means before that, not rest. After that, not rest. What does that mean?
It means it rests for like 1 second, then quickly.
No. One point of time. Just 1 point of time. And before and after not, right? Before and after not. That is a total hint that the acceleration is not 0. Because for V equals to 0, A equals to 0, the speed at this point is 0. Before, also 0. After, also 0. So it's not an instantaneous rest. It's a continuous rest. Fancy word lah. Okay.
Yeah.
Now, why is this guy V not equals 0 but equals 0? Same thing. What? The V here is, let's say, -2. Before, -2 also. After, -2 also. So acceleration is 0. This is physics. Can I accept?
Yeah.
Okay, you have learned this, and please remember that because it is how to say it? It is a counter to what we may think. It is not instinctive. That's why we learn physics. Okay. Okay. We still have time. Now, let's talk about 11C. So what do you do for 11C? You can actually answer 11C already using your past knowledge. Definitely can.
Maximum velocity. Oh, maximum velocity means terminal velocity.
Yes, in physics, yes, I agree.
Yeah.
No need physics here, no need physics here. But I agree, yes, in physics, that terminal velocity is maximum velocity. However, not all maximum velocity is terminal velocity. That's also physics lah. Okay, terminal is maximum, but I'm so sorry, what am I talking about? Terminal doesn't always mean it's maximum. Terminal can mean minimum.
Oh.
Terminal can also mean minimum. If it is, never mind, let's not talk about physics. Let's just talk about math first. Okay, I want to answer your physics question, but later, later. Then we cannot answer the math, right? So maximum velocity in math does not require you to think about terminal velocity. It requires you to think about something else. What is it? Previous knowledge. This one is not new. Previous knowledge.
Oh, is it turning point?
Okay, turning point, maximum, minimum point. So what are you supposed to do?
dy dx equals 0.
In this case, don't say dy dx, but in this case, say
dv dt.
d what?
dv dt.
Very good. What is dv dt?
The acceleration.
Yes, a equals to 0. That's probably the only new thing. No? Oh, dv dt. Oh, a equals to 0. Understand?
Yeah.
Okay, please do that. And then I think we can close for there first. We'll leave the d and e later. Let me see your working. Can I see your working, Aryan? I cannot. Okay, move up a bit more. Move up a bit more. Okay, nice. Good. Okay, so you use the A, and then you found the T, and then Nice. Okay, can say that you're correct lah. Maybe there will be careless mistake, but frankly speaking, your concept is correct. Good. Okay. Now, I won't make too much comment on the final answer. I'll pretend that we don't have an answer key. So the concept is correct. Maybe you may make a mistake, maybe not. Who knows for now? Okay. So to close, Aryan, I take it you don't have a question, yeah? Easy, right?
Yeah.
As promised, ABC, the reading is important. You have to understand the sentences and the question, okay?
Yeah.
The knowledge, you have enough already. And the integration is, frankly speaking, the differentiation and integration. I mean, you haven't even done integration. Huh? You're just doing differentiation. Frankly speaking, it's very easy.
Yeah.
Right? Okay, so it's the reading of the question which is going to be very important. Be careful there, yeah? You will see as you practice. Now, for part D and E, we don't cover today. For part D and E, I will argue that there will be something new. And it is definitely the harder part of the question. When we have time, we'll be discussing this holiday tuition, definitely.
Yeah.
Okay. Anything else for today?
No, we have lesson this Tuesday, right?
I would think so, unless there are some changes, then I will tell you. But let's assume that there is. Okay. So nothing special for the Tuesday, still normal. But after that, then I think we'll have the holiday tuition. Okay.
Yeah.
Take care, Aryan, and I will see you.
Bye.
Bye-bye.